When I go live, I play about 3 minutes of intros, and then I say hello to everyone, and then I'll introduce you, and like you can introduce yourself to my audience, and then I can introduce myself to your audience, if that's all right.
No doubt, no doubt. Sounds good to me. Uh, you know, I like to. Oh, I'm muted up. I'm sorry. I said that sounds good
That's
to
like,
me. I like to give everyone. I like when I meet somebody. I like to meet them on my own and not take any preconceived notions about them. Because a lot of people was telling me, to watch out for you, man. Say you're rude and
yeah,
all
I
that.
mean,
But I
like the
think,
general assumption is that I'm a bit of an asshole, so
well, people kind of say I'm an asshole too. So you know what I'm saying. I think we from the same planet, so we should get along.
and absolutely. Okay, right. Oh, good to go.
You said you're in the UK, right?
Yeah, in Scotland.
Do you think it's possible? I know right off. I know we haven't, a debate. We're going to be making a lot of arguments about the horizon, hopefully, because I saw your debate with Gleason. So I'm gonna kind of, I liked
Oh,
it
good.
that I'm gonna go with some. The horizon is a great place for flat Earth, globe Earth, all the stars, clouds. I like to deal with what made me a flat earther. So hopefully we can get into some of these
Yeah,
arguments. But
there's
as
some
well,
stuff about the horizon I can talk about. Definitely, I've got quite a few things about the horizon that I like to talk about.
okay. And just besides the debate aspect, maybe at maybe not this show, but in the future, something we can have a discussion about the truth community in general. I think that'll be beneficial concerning, the flat Earth, globe Earth, because a lot of people in this
Yeah,
community say, well, the reason it's a distraction from the real things we should be like. We need to know how much of the government stuff do you agree with, how much do you don't, because just because I'm a flat earther, you a globe earther, we may both say, hey, September 11 is bullshit though, right? But we need to learn to distinguish when are they lying and when are they not, and that can be tricky. I don't know if you take everything they say hook, line, and sinker or not. You know what I'm saying?
no, I test everything myself. I always have.
Okay. So I think that'll be a great discussion at some point, maybe at the end of here or in the future or something. I'm interested in that.
It sounds good. I like the idea of that. It's cool. All right, just 1 minute, and then I'm gonna start going live over here. Excuse me. Is that bomb coming back? Right. 1 minute. All right, I'm gonna go live over here, so I'm gonna start my intros now.
Do your thing. Uh-oh, somebody cookie's ready.
We're living on a disk, floating through space, with a tiny sun.
I think her cookie's ready, Becky.
AMFTFE, welcome back to the channel that does to stupidity what chucking someone in the sea with rocks in their pocket does their ability to breathe. Thank you for joining me once again for a discussion about the shape of Earth. Tonight we have a really good one, because tonight I have someone that I have many people that have come to me, asked me to speak to, and that is Brother Sanchez, Bro Sanchez. And he should be on the line right now. Bro Sanchez, how you doing?
I'm doing quite well, thank you, and salutes to your beautiful chat room. Hold on, you know what? I got a little bit of background thing going here. Let me cut that off. Sorry about that. There we go.
No worries.
All right.
Thank you for taking to come and chat to me. And I know you're live on your channel as well. So hello to all the people over there on your side. Now, we kind of talked beforehand that we're not really going to have a debate tonight, more of just a discussion. And I thought, you know, depending on how it goes, we could look at maybe a moderated debate a little bit down the line. So I like the sound of that. So how about you just introduce yourself to my followers in case people don't know who you are? I just take a couple of minutes and tell people what it is you do here on YouTube and what you think about the shape of the earth.
Well, I'm Brother Sanchez, of course, and what I think about the shape of the earth is that, of course, I believe that the ground we walking on is an infinite plane. The root word of horizontal is horizon, which is what we call it. We're going to be talking about that today. But I like to deal more so with ancient cosmology. I know everybody like the words flat earth, but on my channel, I teach ancient cosmology or antique cosmology. It's more of a history course, all right, which whether the ancestors were wrong or right about their conceptions of the universe, it's worth a history lesson that we understood how they conceived it. And you can make up your mind whether you think you agree with the way they conceived it or not. But that's basically where I start from in a nutshell. Thank you.
Okay, well, thank you very much for that. And for your side, I'm FTFE. I run a YouTube channel here where it's mainly I try to debunk the ideas of flat Earth, but I'm kind of moving it more towards a general science communication channel. I love discussing science, explaining science, discovering new things about physics. And the main thing I do really is have discussions with flat earthers. So yeah, thank you very much for joining me, Bro Sanchez. Why don't we just get into it? And you can start with whatever you would say is the best evidence, I guess.
I like that. I like that because a lot of times in previous debates with, a lot of globalists, they start just shooting out questions, making arguments. And it's like, there's a couple of things that led me to being a flat earther. And I tell anybody this, if you're able to undo these arguments, I'll be a globalist again. I tried to debunk flat earth. I got slumped on a couple of things, and I've been slumped years now, and I've just been a flat earther. If you're the person to correct these and answer these for me, you're going to make history. You're going to make Bro Sanchez a globalist today. Now, I doubt you can do that because these... Okay, well, we're going to see. So the thing is, I saw you had a debate with Gleason. I've been kind of looking over your channel since you emailed me and everything. And
yeah, I did. That was fun.
Powerful argument I would like to start with on that one. Could we bring up the boats again from that one? Would that be something you can do? Because you made
from Daz of the cameraman.
Mm-hmm.
Yeah.
You zoomed in on the boat because you said that if the earth is flat, you should be able to pick up the bottom of that boat again. You're right. And if you can't pick up the bottom of that boat, in my opinion, I think it's atmospheric conditions and all that. There are times where you won't be able to, pick up the bottom of it because of mirages, atmosphere. There are some times where we see crazy phenomena on the horizon where you get refraction and reflection, and boats appear to be doubled. Boats appear to be inverted on top of each other. I can show some of those images now. So there are several conditions where we wouldn't pick it up. But and I wouldn't just start with curvature for a couple of reasons. And I want to understand something. Again, how many miles away was the boat again in that image? How many miles away was that?
The boat, the one that's furthest away, I think, was about 12.4 miles. Let's have a look at the details here. And Daz actually did email me a bunch of more information about this with, GPS measurements and stuff as well. So the distant sinking ship, that's the one on the far left, is the Princess Pauline, is at 12.6 miles. The closer ship, the Glorious Mahatta, which is the one in the center, was at 8.86 miles. The camera was about 30 feet above the water. It's a P1000, and it obviously it zooms in.
Okay. So
like you said, the claim of flat Earth is that, you know, if the Earth was flat, then the more you zoom in, you would be able to bring that boat back above the horizon, and that's what this was to test. And what he did, let me just talk you through it if you don't mind. So as he's zooming in, he takes a screenshot. So where is it? He gets to about here, and he takes a screenshot as he's zooming in, and then he allows it to zoom in some more. And then what it shows is that once you zoom in, the screenshot from when it was zoomed out matches the proportions exactly of when it's zoomed in. The only difference is obviously there's a bit of blurring because, you know, there's less angular resolution per pixel. But as you zoom in, you can see that the proportions between the masts, the amount of the bridge that's shown, the towers, it's all exactly the same. And you even catch a bit of the ship on the left where you can see slightly the hull is hidden by the horizon, and the proportions are exactly the same. And that this is showing that if you zoom in, it doesn't change what is visible. And he chose this day specifically to do it because there was minimal refractive conditions. You know, there's, you know, I'd say practically zero distortion on the ship. Okay. You know, you can even see in the distance some of the hills of islands a bit further. So I'd say this is a day. Obviously, there is refraction. There's always refraction. But in this particular instance, I'd say the refraction is pretty minimal. And it allows us to zoom in and compare the two between zoomed out and zoomed in. And it shows that zooming in does not increase what is, you know, what is visible above the horizon.
Okay, can I say something based on what I'm observing from this image? Yes.
Please do.
I would say if the Earth is a globe and this is the amount of curvature that's hidden, then it would clearly be the size of a golf ball in relation. Like that's like Niagara Falls we're talking now. That is a big cutoff. If we were like, that's almost like a mountain's edge, almost. You know what I mean? Like to say that. Okay, go ahead.
Sorry, no, I didn't mean to cut you off there. You finish your thought.
No, you're fine. I'm cool for interjection.
Okay, so the thing with this is that it shows obviously further than we would generally be able to see without any kind of refraction. That's what refraction tends to do. It lifts things up. And the difference between the two ships, the difference between the bigger ship here, or the ship in the foreground and the one behind the horizon, is about 4 miles. And what you see is there's probably about, you know, I don't know, 10, 15 feet of that ship that is then hidden from the horizon.
Let me ask a quick question. How many miles do we have to add for that ship to be completely hidden now? We don't see it at all, would you say? Probably about another 20 miles.
Based on I'd say maybe less than another 10 miles, and I think that ship would near enough completely disappear.
Okay,
but it's
now
hard
let me ask.
Don't know what the refractive conditions are.
No doubt.
You go out to sea, you know, you tend to get conditions that change compared to when you're closer to inshore. So you know, that would be a hard thing to determine. But
hold on, let me ask a quick question real quick.
Yeah, go ahead.
You're saying that about 20 to 25 miles roughly that ship will be hidden by the curvature of the Earth. Now, submarine periscopes come just off the surface of the water, and the longest submarine missile attack was about 3,000 miles. Submarine periscopes can see way farther than.
So I'm just
saying.
I was in the Royal Navy as a submariner, and
so answer this question for me: how can periscopes see over curves?
They don't see over the curves. Periscopes tend to do the same thing as a sextant and sight angular elevations of things above the horizon. And submarines also don't fire in a straight line. If something comes out of the water, it fires in an arc.
Oh,
but
really?
Periscopes aren't. In fact, when you look at, for instance, the US Navy railgun, it's designed to be ballistic for the first half of the flight and then use gravity assist for the second half. And that tends to be the case with pretty much every ballistic missile that's fired from a military.
I got a question. If submarines, if their missiles are launched in an arch, do they also swim in an arch so they don't, fly out the surface of the water? They will have to maintain a kind of a
Okay, so
nosedive there.
the answer to that question is to do with the depth of the water and the density as you go lower. So even if the Earth is curved, right, we know that the deeper down you go, the denser the water is going to be, right? So what a submarine does is it adjusts the ballast in its tanks to match the density of the water outside, so that the submarine is relatively same density as the water outside it. And once it does that, apart from little bits of trimming here and there, because it's very hard to keep it steady, but once you match the density of the submarine to the water outside the submarine, you're going to stay at that depth, even if the Earth is curved and that depth follows the curve. The only way to raise or lower on a submarine to surface or to sink is to physically change the density of your submarine, which changes, one of the variables in the buoyancy equation and allows you to control how far up and down you can go. Have you ever? I don't know if you've ever been in a submarine, but they're very scary.
No,
things,
I've
right?
never been in one.
So one thing we did that was always quite fun was before we dived, we would tie a bit of string from one side of the hull to the other, right, and make sure it's taut. And then what you find is as you go down, as you dive, that bit of string that was attached between the two walls of the submarine, the two sides of the hull, it actually, instead of being like that, it starts to, get more and more, because the submarine is actually compressed by the water outside. That's off topic, but I always find that interesting, that you can physically see that the thing you're in is shrinking. It's crazy. But
okay.
Yeah, anyway, so submarines use density that's how they do it. But it's kind of irrelevant to this picture, if you don't mind me saying, because this picture, regardless of the actual distances involved, because we know that refraction changes apparent distances. What this shows is that there is A, something hidden behind the curve of the Earth, and B, no amount of zooming will bring something that is physically hidden by the horizon bottom up back above the horizon. Do you agree with that?
I'm understanding your argument. I'm understanding your argument. Yeah, I agree with you. Go ahead. Continue. I'll rebuttal when you're done.
Well, I'm done for now. That is the explanation. The main point is that the actual distances involved aren't the important thing here, because refraction, even like you said, different atmospheric conditions can change how far you can see and stuff. So we know that it's very hard to determine just by looking at something how far away it is. What's important is that it shows that something is physically hidden by the horizon, and it shows that there's no difference between the amount visible when you're zoomed out and when you're zoomed in, which kind of debunks a main flat Earth claim of well, you can just zoom boats back in once they've gone over the horizon.
Okay, you're done. I'm gonna end up screen sharing here, so I wanted to know if you.
Yeah, sure.
Yeah, if you have it unlocked. All right. Let me grab.
Oh, sorry. Let me unlock it. My bad. It's set generally to not. So there you go. You should be able to screen share now.
Okay. Thank you. So you're okay. So. All right. And quick question before I start my screen share here.
Yeah.
So, same thing with the submarine missile making an arch. Let's say a sniper is picking off a target. We're talking miles away. These snipers, they breaking records nowadays. Do his bullet also makes an arch over time? Just 100%.
So have you ever seen a sniper scope? Right? When you look at a sniper scope, it doesn't just have a crosshair, okay? It will have a crosshair and then a long line, and then below that crosshair, you'll have a series of shorter and shorter lines. That is a distance indicator showing how much the bullet will drop based on how far away they are. There's actually an experiment that Mythbusters did to show that a bullet falls in an arc. So if you were to fire a bullet and from the same height of the gun, drop a bullet right next to it, even though the bullet fired from the gun will obviously go forward, it will hit the ground at the same time as the dropped bullet, because the acceleration of gravity is acting on it the second it is released from the gun. So bullets absolutely fly in an arc, and you one-hut snipers, depending on how far away they are, they have to more and more take that drop of the bullet into account.
Well, the fall of the bullet ain't necessarily an arch. We talking an arch, we talking like taking a basketball shot. You're aiming up in the air to make a arch, not in a straight line. If I throw a basketball, hold on.
Sorry, my bad.
Hold on.
Nice.
If I pass a basketball from my chest in a straight line, over time everything will drop. Is what I'm saying. We know that he's shooting a straight shot. You're talking about he's throwing a bullet over a curve now. It's almost like he's making a shot over an arch, but he wouldn't be able to see the target if there's an arch there. There's no way he would be able to line his sights up with a target that's hidden behind curvature and launch the bullet over the curvature and make an arch shot now instead of a straight shot.
So snipers don't tend to fire that far. I'd say a normal kind of long-range sniper shot would be, under 1,500 meters, which, 1.5 kilometers, you're generally still going to be able to see things in the distance. That's not really far enough to, have things obscured by the curve of the earth. But interestingly, when a sniper's, sniping, there are other things that a sniper has to take into account, as well as the drop of the bullet over distance. And what they have to take into account changes depending on the direction they're firing and whether they're in the northern and the southern hemisphere. And that's called the Coriolis force, the Coriolis effect. And I've got snipers that have sent me tables showing, that this is a known effect. And the rotation of the Earth imparts an apparent force onto a moving object, a freely moving object. And you can actually see that, for instance, if a sniper was at the equator firing north, that bullet for them would drift to the right, which would be technically ahead of the rotation, because the conservation of momentum means it's firing for one tangential velocity that's higher moving into a lower.
Okay.
So snipers not only have to take, the fact that a bullet drops into account, but they actually have to, depending on how far they're firing, they have to take the fact that the Earth is rotating into account.
Okay, so I'm just getting my notes here for our future arranged debate, kind of seeing what your arguments is and all of that stuff, testing the waters for the future debate here. I know I know you're not showing your whole hand, but that's all good. I'm liking this bill. I'm gonna go ahead with that screen share right now.
Yeah.
And
before you give me just 1 second to add that. Yeah, that's the one. Okay. Yep, you're up.
Okay, so I just got a simple little image here of, just to remind us of how reflections appear on a curved surface. You said that the curvature of the image you showed, the ship start to hide itself at around 10 to 15 miles, I think you said. And
that particular image, yes.
And you said also at around 20 to, I'll say roughly 30 miles, we definitely wouldn't be able to see no ship. So with that in mind, I want to take a look at these images and talk about the salt flats in Bolivia here. This is an area of 6,000 miles wide, 6,000 mile area here, 10,580 some kilometers, something like that. And again, the pattern in the sky will mirror itself on the ground for over thousands of miles. You walking on a mirror, and how to know that it's a flat mirror is that you get a perfect reflection and not a distortion, meaning that if something is being reflected on a ball, especially over now, I'm dealing with thousands of miles now. We're talking a huge mirror. And if this mirror had to be wrapped to a ball, it will have to arch and distort the image, showing us that the surface that it's revealing, because we can reveal this with a mirror now. If there's a mirror that we have here, which is what the Bolivian salt flats is, we will definitely get a distorted cloud image in the background, and we'll be able to count for the fact that the mirror is a sphere and not a flat mirror, giving us a perfectly mirrored image. We don't buy spherical mirrors. Those are called disco balls, I think. But I know one thing: your reflection in a spherical mirror will never be the mirror image, as we call it. So to have a mirror image, what we see here, you know, to me, over 6,000 of miles, this is one of those arguments that had me slumped when I tried to debunk flat Earth. You want to talk about this?
Yeah, sure. So the thing about the salt flats is they aren't flat. They are actually measured to be curved.
They're the salt curves. Salt curves.
I mean, they look flat, and that's why they're called the salt flats. But to first talk about the curved surface thing, absolutely, the more something curves, the more it will distort the image. The curvature of Earth is so slight based on how far those distances are that the distortion will be very minimal. Now, here's
let me ask a question based on that. If you said the ship will be vanished by the curve at 20 miles, then we should definitely see distortion at thousands of miles, though.
So, again, over water, it's very different because refractive conditions over water are very
okay.
Over salt flats. Obviously, over water, you tend to get a much steeper difference in temperature and density than you do, say, over the salt flats. But what you said about the spherical mirrors is very interesting. You said we don't buy spherical mirrors. Do you know how, in general, mirrors are made? So, right. So mirrors are made by a process called float glass, right? They fill a big bath with like a liquid metal or something that allows you to then pour the glass on top of that for it to set. Now, these baths are so big that the arc of the curve of the Earth can actually be measured over them. And according to the manufacturers of particular float glass, the arc of a mirror they produce will match the arc of the curve of the Earth. But it's so slight, you know, it's 1 degree for every 69.1 miles. It's
Are you
so
saying
slight.
There's no such thing as a perfectly flat mirror?
In general, based on the way that they are made, there is not, because even the people that make it say that the curve of the mirrors that they make using float glass will match the curve of the Earth.
What about the level that we use to hang the mirror that's fooling us that it's making the mirror perfectly parallel to a flat horizon?
Well, it's perfectly horizontal, you know, it's perfectly plumb compared to your specific point of down. You know, level isn't flat and changes based on the curve. But let's carry on with the salt flats.
So when we say sea level, we're not really, again, it's not the salt flats, it's the salt curves, and it ain't sea level. It's basically sea curve. But
what level actually, when you're talking about the Earth, means curve. The definition of level.
Oh, level means curve.
True level is the curve of the Earth. If you look in Merriam-Webster dictionary under the adjective, which is the describing word, it describes curve as conforming to the curvature of the liquid parts of Earth's surface. And if you go to mctoon.net/level, there's 45 citations from different surveyors and people that actually use leveling tools that talk about how on Earth level means curve. But I want to quickly go over the salt flats, because there is actually very way to see that the salt flats aren't flat. And that's one way, is taking a photo of some of the roads that go over the salt flat. And I think this is a particularly good one. This is the Bonneville Salt Flat. Interstate 80 traverses the Bonneville Salt Flats. And you can quite clearly see there that there's a curve to them. And if we have a look at let me just get this picture up, the Salar di Uyuni Salt Flat. What somebody did on that one was, as they were traveling across the salt flats, they took photos of mountains in the distance as they got closer. Come on, there we go. And this one shows that from 27, from 83 kilometers away at the bottom there, you can see a lot of the mountain is hidden. But the closer they get, less and less of that mountain becomes, more and more of that mountain becomes visible the closer that they get. So they got points there, 1, 2, 3, 4, and 5. And as they get further away, observers see less of Mountain Upper the further they are from Salar di Uyuni. I'm sure I pronounced that all completely wrong. But Bro Sanchez, the fact is I've got many, many examples of evidence that salt flats aren't actually completely flat. They are level. Salt flats are level. And when you're talking about Earth specifically, level means conforming to the curvature of the liquid parts of Earth's surface.
Well, I just learned something. All these years I thought that the word level meant what the word says, but hey, I'm gonna have to look into that. I'm just gathering information for our future debate.
Absolutely.
For my
again, you can find the citations for that on mctoon.net/level, where there is 45, I think 45, maybe more than 45 citations that
wow.
You know, level means curved. Let me just quickly show you some of them if you don't mind. So George Hatnick, who is a surveyor, a level surface is one that is everywhere orthogonal to a plumb line, meaning that any tangent to the surface forms a 90-degree angle with a plumb line at that point. If we look here at a leveling manual that surveyors use, quite an old one, showing that it's not just a new thing. Leveling is the art of ascertaining the perpendicular ascent or descent of one place or more above or below the horizontal level of another for various intentions, and of marking out courses for conveyance of water. The true level is a curve conforming to the surface of the Earth as ABG. So this shows that this would be level, ABG, following this, and the line above it would be flat. From Webster's Encyclopedia Dictionary, level, a surface which is everywhere perpendicular to the direction of gravity, which is down at wherever you are locally.
Wait a minute.
Yeah.
Level is anything perpendicular
to the direction of gravity, which is down at any point for you on the Earth's surface, if the Earth is a sphere, down the direction of gravity directly below you. Level is perpendicular to that.
So
it would mean it would follow a curve.
Yeah, I understand that, but I just don't understand how just because even though gravity is a theory, I'm just saying we're going to talk about gravity in a minute. Don't you think that's kind of bizarre science? That's not really the scientific method. That is crazy that you're basing what level is off of a theory when level is really what we can prove and see is sea level is flat. All the instruments that we use is based upon the Earth being flat over a level horizon. But the image that I'm showing on my screen now is Lake Pontchartrain, and it's this image is actually over 20 miles long of road that we're looking at, and you're showing me a road a minute ago. I'm trying to see how it compared to this one, and then I'm also trying to see. Also, can you explain why the people that built this bridge, why the columns that's in the middle of the bridge aren't shorter than the ones on the edges? Because if it's following an arch, you shouldn't have columns from the beginning and end of this bridge that are the same height. Wouldn't you agree?
Well, no, because the height of the columns would be relative to whatever the surface of the water is at each point, which is, what level is. But when you say Lake Pontchartrain, I mean, surely you've heard of Soundly and his, images over Lake Pontchartrain that show that.
I haven't really. No, I don't really heard of Soundly.
Soundly is someone who is very into photography. And what he did was he went to Lake Pontchartrain and did a live stream. On the live stream, he had a camera pointing from the hotel he was along Lake Pontchartrain, and he was letting people control the camera. And what he captured when you're looking along that bridge that you're showing is this, which shows that when you're looking at it directly on, I'll get a higher depth picture than that. Sorry, one sec.
And then we can talk a little bit more about gravity as well at some point, because
absolutely. I love gravity. It's a great thing. So yeah, as you can see, when you're looking directly, along the length of the bridge, you can see the bridge is level to the surface, but that level happens to be curved. And that wasn't the only thing that they did. They also took the images of the power lines, which go over Lake Pontchartrain, which I think run parallel to that bridge. And if we have a look at the power lines, what we see is the same thing. That even though each of those power lines, each of those towers that carry the power lines are the same height, and they're all the same height above the water, the further into the distance, you can see that it curves more and more, which matches. And there's actually, what's his name? Walter Bislin, who writes programs that model out things. He modeled out this and compared it to a flat Earth and a globe, and it matched the predictions of a globe. So when you're looking over at Lake Pontchartrain like this.
Oh, okay, yeah, I do remember these images here. Soundly is the one that took these.
Yeah.
All right.
So
well,
the reason why this one looks flat is because you're much higher above it. And imagine if you've got a ball, right? And you drew a straight line on that ball and you looked at it from further away, it would look straight, wouldn't it? Right? But as you got closer to the ball with that straight line that you've drawn on it, that straight line will appear to get more and more curved as you get to the surface, because it is literally a perspective thing. But when you're close to the surface, you see that bridge that you're showing right there is actually curved.
Let me show that on my end, if you don't mind, because I'm still showing my screen share. I just thought about it. Keep your the image up real quick. Let me get out of this real quick. I want you guys to see on my end the image that he's showing here. There you go. So guys, you see he's showing how the bridge is curved in the background there. Now, what do you say to somebody who say that looks, man, that really looks, I hate to say it, but it looks kind of fake. It looked photoshopped. I hate to say that because that's kind of like everybody like to do that. Yeah.
But here's the thing, though. This was from a live stream. This is a still from a live stream, not just a picture. He did a live stream from the hotel window.
You know what? I'm gonna go and check. I'm gonna go ahead and check that out.
Watching the live stream to control the camera.
Okay, so listen, just for intellectual honesty, I didn't see the live stream, so before I make an argument for it or against it, I think it's honest that I go ahead and do my homework after this.
And I will send that to you. Anything that we talk about that you'd like more information on, please do let me know, and I will email those to you.
For sure. I'm definitely gonna need this Soundly. Salutes to Soundly. I'm gonna be checking them out now, y'all.
He did a great job. He did he did what people asked. He did the pictures that people were asking for, and he did a great job doing that. A lot of props to Soundly. This is a very famous picture because of him.
Okay, so I'll be checking that out. I tell you what, then, if we'll make in our future debate, we will make Soundly's information the basis of our Horizon argument. Then I'll go ahead and check that out and make my arguments around it. And because you will be presenting some of his stuff for your argument for the Horizon, right?
I mean, I tend to switch. I've got so many arguments that I tend to switch stuff up. But if you would like me to talk more about Soundly's observations, then I can do that.
For sure. I think that's very interesting. We could skip back to
the chat says Soundly actually turned the camera upside down live. And if the camera had some trickery, turning it upside down would show that the curve was in the opposite direction. So he did everything he could during the live stream to make sure that, people couldn't claim fake.
Okay, so now let's do this too. We're gonna skip back to the horizon conversation here. Let's kind of skip around and go to gravity and kind of go back and forth with some things here. With the gravity thing you said earlier, so gravity is pulling everything toward the center of the globe, correct?
Yeah. So,
Okay.
just to be clear, what we say about gravity, what Newton's universal law of gravity says, that there is an apparent force of attraction between two bodies of mass that is proportional to the mass of the two bodies and inversely proportional to the square of the distance between the centers of gravity.
Is this Newton's fact, or just he was theorizing a force of what?
No, it's a law. It's a natural law. It describes Fg equals G m1
Okay,
m2
go
over r
ahead.
squared, and it's been empirically demonstrated to be a fact many times. Obviously, most famously with the torsion bar experiment, but that's why it's called a law. Newton actually never had a theory of gravity.
I don't want to throw you off. You were explaining it. Go ahead. You can finish explaining it. I'm sorry about that.
That's okay. So Newton never actually had a theory of gravity. That's kind of a misconception. Newton only ever gave observations, right? Newton saw something happening. He saw this acceleration, of bodies towards each other, and he could describe it mathematically. That's all Newton did. He saw what happened. He had an observation, and he wrote down what that observation was mathematically. And it's an equation that allows us to predict many things. It allows us to predict the orbits of planets. It allows us to predict the acceleration of items depending on the...
I got a question for you. How are the Vedic... Most of the world today is still using the oldest astronomy system, and that's the Vedic system. Even the Western world currently we use is all founded on the Vedics, who created astronomy and also have the oldest system and most accurate system on Earth. I want to know how these flat earthers also were able to make the same predictions. Could you explain to me, making these predictions, you can make them whether you know that the ground you're walking on is flat or round or in motion or not, you still could be able to make these predictions on both ends? Will it matter, or would you say that? What would you say to that? To the ancient people who they navigated using the stars in the ancient world, and they were flat Earth people. What do you say about that? I'm just picking your brain.
So ancient people used their local knowledge and patterns. It was as simple as that, right? They saw a pattern. They saw a pattern repeated. They, based on their very local, area.
I'm talking about making astronomical predictions, though.
Yeah, but here's the thing, right? The astronomical predictions that they make were not very accurate, right? We can use helium.
Oh yeah. Let me hold on. Wait. The pyramids at Giza still aligns to Orion to this day.
Incorrect.
The pyramids at Giza.
So here's the thing: the pyramid at Giza is one arc minute and 54 arc seconds off of the matching up with the pyramid of Giza. The star above it does not line up anymore compared to how it used to. I
totally disagree. I totally disagree.
It's been measured, and actually the shift of the stars is recorded in astronomical almanacs. And even more recent than that, the Georgia Guidestones, which were, I think, raised in the 70s or 80s, which cited a star through them, that star is now wildly off. It doesn't even line up with the circle because it's closer to the north.
Will we ever get a complete new set of constellations as we're hurling through this universe? Will we ever get
maybe not a complete new set, because what you have to understand is that all the stars that you see in the sky, all of the stars that you see with your naked eyes, are pretty damn close to us, right? In galactic terms. And all of those stars are traveling around the center of the galaxy with us, at relatively the same speed.
And they're synced.
Yeah, I mean, not 100%, because obviously there's going to be slightly different tangential speeds and stuff, which is why there does tend to be a procession of stars over time. During the 1000s to the 1100s, sailors noted that the north celestial point of rotation was a void. It wasn't Polaris. So 1,000 years ago, the point of rotation in the north where all the stars go round, it wasn't Polaris. It was a void. It then, as the centuries went on, they reported that Polaris moved into that point, which is what we expect to happen.
Is it safe to say that it was not a void? It was always Polaris, but some people theorized that it may have been a void. Some people theorized it was a monster. Some people theorized there were no, I'm serious. If you look at some, I swear, I do.
The actual observations show that, you know, they knew where Polaris was, and it wasn't the central point of rotation of stars in the north. That has only happened over the last 1,000 years, that it's become exactly that. Even in the 16, 17, 1800s, the amount of wobble around the rotation, which, you know, Polaris that they used, the wobble was more and more, and it's become less and less. Because as time has gone on, Polaris has become more in line with the axis of rotation. And what we expect to happen is, in about 20,000 years, that precession is going to continue, and the point of celestial rotation will actually be a star called Vega.
Okay, all of that sound good, but the ancients used Polaris to navigate for centuries, and the fact that you're saying that, well, I don't see how that can be so consistent throughout thousands of years and ages if these dramatic changes are happening. If you consider parallax. But let me I have another question for you. I didn't really want to get on Polaris because it was something about gravity that I wanted to get on.
Okay, all right.
We kind of got off with
navigation, because there's something I want to go through with you about the stars and stuff that I think really kills the flat Earth. But let's continue with gravity. So we were talking about Newton's law, right, which is just an observation, and that allows us to make predictions. And what Newton's law shows is that it's not just, you know, a drop towards the Earth, an acceleration towards the Earth. It's an attraction between all mass. Have you heard of the Cavendish experiment?
Yes.
Right. So the Cavendish experiment is a torsion bar experiment. Okay. So a wire, a torsion bar with mass on each end, and then you introduce larger masses to it, and it shows that there's an attraction that is inversely proportional to the square of the distances and proportional to the mass of the two bodies. And every single person in the world that does a physics degree literally does this in the first month that they're at uni. And if you go to Blue Marble Science or Ian Furbal's channel, they built their own Cavendish experiments. And what the Cavendish experiment does is show that there's an attraction of mass that not just up and down, but it's side to side of the same magnitude. So we're able to calculate the acceleration of gravity, not just up and down. So it's not just things falling, it is literally side to side as well.
Okay, so now the basic rule though is everything is being pulled toward the center of the Earth. But I want to. Okay. Now hold on. Wait a minute. I got you. We both understand that's the basic rule. If that's everything is being pulled equally toward the center of the Earth core. I got you. I'm trying to make another question based on that. We got to explain now why things float, because I don't think gravity do that. It only explains why things fall or sink. And
that's fine. No worries.
Yeah, but hold on. And I wanted to also ask you, is gravity a selective force? Meaning, when I look at nature, forces of nature aren't selective. The fire will do the same thing to me that it will do to you. A tree is gonna. Forces of nature don't seem to be biased. What I would say is this right here. If gravity is a legitimate force of nature and not a theoretical force, can you explain why it seemed to be so selective? For example, people say gravity is pulling everything toward the center of the Earth, and it's holding all this water in the ocean on a globe, but yet bubbles can escape the pull of gravity. You know,
Right.
Think,
Yeah.
think
So that's
the
absolutely
bubbles
fine.
afloat to
So,
the surface, things like that.
yeah.
So I think density is the more legitimate natural law, which we explain on flat Earth versus
Okay.
gravity, because yeah,
So here's the
just
thing. Gravity imparts one force. Gravity just gives one force. But there are other forces, right? And there's one particular force. So you talk about things floating, and that's called the buoyant force,
I knew you would
right?
say that.
And there's a reason I say that, and because to describe the force of what was that?
Was
Is
that
coming
you?
from you?
No, it wasn't for me.
Where's that coming from?
You hearing something?
Yeah,
I don't hear nothing.
music. I think it's coming from you, apparently.
I don't hear nothing on my end coming from me at all. We streaming on my end just fine. And if I had any audio, my meter would be letting me know of any audio coming in my.
Right. No idea what that was. That was weird. Right. Anyway, so the buoyant force is described like this. So FB is your force of buoyancy. And
I understand buoyant force. I understand it.
Yeah. Rho.
Save some time.
G, V. Okay. Rho is the density of an object. All right. V is the volume. Rho is the density of the medium. V is the volume of medium displaced, and G is the acceleration due to gravity. All right. And when you take these things together, it allows you to calculate the force in the opposite direction. All right. So a way to explain what the buoyant force is with a balloon in the air. So
that's wow.
Okay, so let's say you've got that balloon, right, and it's floating up, which you guys say is going to go against gravity. But here's the thing. This balloon is less dense than the air outside of it. All right, it's got less mass than the air outside of it.
Yeah, you're dealing with density right now, though. That's what I'm saying. It goes all the way back. It's going to always go to density, though.
Yeah, but let me finish, right? The reason it happens is because of the air outside has more density than the air inside.
I totally understand.
This air is pulled down with more force than this balloon is pulled down, right? So you've got a bigger arrow going down and a smaller arrow going down. And because the air around the balloon is pulled down with more force, that creates a force in the opposite direction to gravity, pushing the balloon in the opposite direction. The air outside is being pulled down more than the balloon by gravity, which forces it up. Density is important because density, rho, is one of the variables in the equation for buoyancy.
Okay,
it's how
so
you calculate what
got
the buoyant
you.
force
Now, I would like to explain it, and I'm going to do a screen share as well.
Yeah, sure.
And I guarantee you that I can explain. I guarantee you that when I explain this, I will not need gravity. I will not need buoyant force. You're dealing with forces that are pushing and pulling on things, and I'm coming from a whole nother perspective that I think is a better approach, and you can decide. But let me go ahead and
Please do.
Hold on, I got the wrong screen share on my end. I got two different screens up. Let me share the right one with all of y'all. 1 second. Sorry about that.
That's okay. That's okay. There's a couple of things that that have happened recently that I do want to talk about after this.
Okay, there we go. I got it.
One thing which has been excellent evidence of the fact that you're.
Got you. So, in your opinion, there's one force pushing objects up and one force pulling objects down. And you say gravity and buoyant force. I got you. I totally got you. I learned it too. Now, the thing is this. I don't need these mysterious forces that's pushing and pulling on things, because once you get into a push and pull match, somebody can say, well, buoyant force won the match if the helium balloon floated upward. I guess gravity lost that one. And this is like a duel now. Okay, buoyant force is the winner here. And sometime buoyant force wins, sometime, this is a very theoretical way of explaining such a simple natural phenomena, and it's explained with one simple word: density. If an object is less dense than the medium it is in, it will float. If it's more dense, it'll sink. Gravity says all things that go up must come down. But if they stay up, then we say, well, buoyant force pushed it up. Well, you can't have your cake and eat it too. I have one law in the universe that can explain how things behave in our reality, and we can look at the periodic chart and see that dense metals settle deeper in the ground than less dense metals. Dense gases settle lower in the atmosphere than least dense gases. Nature is a neat freak, and she's stacking things according to the law of density, and there's no two forces needed to explain this, such as push and pull, that's having a duel. Hold on. Okay, go ahead. Interject.
Sorry, I'm saying there would need to be some force, though. There would need to be a force, because let's say that you take that key, right, that's at the bottom, and you drop it in the top, okay? That key is going to accelerate through those layers, right? That acceleration, because F equals ma, force equals mass times acceleration, that means there has to be some kind of force being applied to move that key from one area to the other. And density isn't a force because it has no way to decide.
Well, here's the thing. There's not a force pushing or pulling the key to the bottom. The key is actually following a law called density. There's a universal law that the universe set, and everything in nature follow that law. And that law is, and hold on, wait. Hold on. Wait a minute. I just started. That law that the universe set is things that are heavier than the medium they're in will sink, and things that are lighter will float. There's no two forces pushing and pulling that key. The key is simply following the law. That's it. Everything in nature is governed under universal laws, and forces. Okay, go. I'm sorry. Go ahead.
Yeah, gravity is a universal law, but you have issues.
No, gravity is a theory, right?
No. Gravity, again, as I described earlier, Newton's law of gravity. Gravity is literally a natural law of the universe that is described very, very well. The issue with density
how can gravity be a law, but it has a opposite counterpart called buoyant force? When you talk about universal laws, there is no forces within it. The forces even follow these laws.
That's a very different definition to law than I have ever heard of. Do you have a citation that that's what a law is?
What do you mean a citation that's what? Listen,
well,
if you let me tell you,
a law is described as something that is that allows you to make predictions, right? That is
a scientific law
and inherently shown. So a law like gravity can describe what's going on here. What you're showing in this density tower can be explained by gravity, right?
Listen. Wait a minute.
One sec. Please give me 1 sec. The reason I asked about the key falling is because the key will be accelerating, right? That's an acceleration. It goes from not moving to go through those layers. And that acceleration requires some kind of force, and that force is imparted by gravity. But what happens, Bro Sanchez, if you remove that downward acceleration, right? If you take these things that are in these layers of density, what happens if you remove that downward acceleration? What happens to that density tower?
You tell me.
Okay, I'll show you exactly what happens. If you remove that density tower, then they do not, if you remove that that downward acceleration, you do not.
Okay, here we go now. I knew it'll go there.
So this is a parabolic flight, a simple up and down in an airplane. And as the plane is flying level here, you've got the density tower arranged as you had on your picture. All right. The more dense things at the bottom, the less dense things at the top.
Okay, so but what you're saying is you're saying they behave differently in these upper layers, correct? Yeah, right.
No, that's not what I'm saying, right? As the plane is flying level, right, the density tower is arranged with denser things at the bottom and less dense things at the top.
Gotcha.
But a parabolic flight, dives down sharply, right? And what that happens when you dive down, it allows people to float and stuff in the plane because it cancels out the acceleration of gravity because you are going down, right? And if you remove that acceleration due to gravity, watch what happens to the density tower. Here we go. So here we go. As they start their parabolic flight and everyone starts to float, the density tower is no longer arranged with denser things at the bottom and less dense things.
That's what I was saying. That's what I was saying.
The only difference is that the acceleration downwards due to gravity has now been removed. It's been cancelled out. So the only difference in the density tower here and the density tower here is an acceleration downwards, which is caused by gravity, which means that the natural law of density that you said all of a sudden disappears as soon as you remove an acceleration downwards due to gravity.
So that's a good little video there, but we're dealing with density independent of gravity and buoyancy. When you have to go to videos like this of them in a G-plane and all of that, to me, I don't think it's a relevant and accurate argument to what I'm showing on the screen, because we live on the ground and we're talking about how reality behaves on the surface of a flat plane or either a globe. You see what I'm saying? And this is the nature of our reality here, which explains why ships are able to float. And you see what I'm saying? When we deal with density, you got to explain to me, because you're showing me a great example of falling force, or what we call gravity, but you're not telling me when the fall is stopped, when things settle, as we call it. Like this cup is sitting on a table. If we remove the table and this cup is suspended and it began to fall, of course the law of density is not going to be at law. The law of density can only work if you're on a stationary surface and on a flat surface. That's why I said a video you showed is kind of not explaining what density really is.
Video that I showed explained when you remove the acceleration downwards, the density towers. And what I'm showing here is also another example of that. Okay, so he's
see
got
what you're showing. Hold on.
Can you see it?
Yeah, you need. No, I'm screen sharing. I think I was going somewhere with the. Yeah. I see it.
So as you can see in this bottle, right? He's got that's hanging. He's got a straw with air going down to the bottom, and you can see the bubbles going upwards, right? Due to buoyancy. But the same way with the parabolic flight, right? The same way with the parabolic flight, he drops the bottle. Let me move it a bit forwards more so you can see. That's it. All right, so he drops the bottle, and as he drops, here we go. So as the bottle drops, what you see is that the bubbles stop moving upwards, right? Because in the same way as the parabolic flight, you've removed that downward acceleration due to gravity. So let's just see that again so you can see it a bit clearer. All right, so as it's just standing there, just hanging there, the air is going down, and the buoyant force is making the bubbles go up. Okay, but as I showed earlier, part of the buoyant force is G, which is the downward acceleration due to gravity. And if you cancel that out by letting the thing accelerate due to gravity, it shows that density, as you want to call it, or buoyant force as we call it, no longer works, and the bubbles stop moving within that reference frame, showing that once again, density all of a sudden disappears as being a force of things.
Let me explain something to you.
Right?
Density never disappears, because when density explains a object's position once it settles, not when it's in motion to be settled. For example, running water is in motion and it's following the law of density because it's in motion, finding sea level. It's seeking sea level. It's seeking. So when you, for example, if you contain the water and you'll get this flat surface like we see on the screen where it settles versus someone trying to, for example, I'm just saying, you're explaining running water versus settled water in your scenario. That's why I say it's kind of relevant to the argument that I was finna make with this image. I'm agreeing with you, whether you want to call it buoyant force or whatever you want to call it, that if we set this thing in motion the way you're saying it, that the law of density still is at work. The law of density isn't absent because the nature of the objects changes based upon you changing their motion. You're moving this. You're like, for example, in the G plane, you're basically shaking the doggone cup. That's why I say I'm making my argument based upon where things. Wait a minute, hold on. I'm making my argument based upon where things are when they settle on Earth. Why the atmosphere is above the sea level and the clouds don't fall, and our atmosphere don't swap places with the ocean, and heavy metals settle to a certain depth, lighter metals settle at a higher depth. You know what I'm saying? I'm trying to explain when things settle, because my argument is based on a flat Earth that's not in motion.
Not in motion. There's an excellent one.
Right,
okay, we can go there as well. Right. So let me ask you a quick question about that then. Why does the law of density not apply when things are moving?
Because when things are, for example, right, if I shake this cup up and I keep shaking it, the law of density, it won't apply because it's in motion. Soon as I stop shaking the cup, everything will follow the law of density and settle back out to their respective layers, and it'll just like blood in a container. The blood will separate itself in different layers. You'll see it from red, yellow, and white, clear layers. But when it's in motion, when it's in your veins, it's actually, you know, you can see this happen if you ever pour orange juice in a cup. They tell you to shake it well, because you can see the different layers forming at the bottom of thickness, just like this density. Right. You can see the pups. Right. So what I'm saying is, if you want to explain why the orange pup ain't settling in the bottom of the orange juice when you shaking it, that's kind of a silly question when you agree.
Stupid.
Okay. So here's the thing, right? Your law of density, as you call it, can explain why things are arranged when it's perfectly still. However, the law of universal gravitational attraction can explain why things are arranged that way when they're still and when they're moving and other forces are applied, right? But it's not, gravity isn't just a downward acceleration. It's, you know, the density tower kind of doesn't explain a lot of other things about gravity, like how we can show that it's an attraction side to side and not just up and down. We can physically measure it. Not only can you use a torsion bar.
Say that. I didn't hear your last statement. I'm sorry.
So, you know, the density that you're claiming can't explain why there's an attraction side to side of things, right? You know, it's not just up and down. It's, as the Cavendish experiment shows, there's an attraction between things.
So things can fall sideways.
Yeah, that's exactly what the Cavendish experiment shows, that there is an attraction between things sideways. It's very small.
Can things fall up?
Yeah, again, that's because there's other forces, buoyancy.
Wow. Okay, so is there
experiment with Cavendish experiment?
Hold on, quick question. I got you. Quick question based on what you just said. So based on what you saying, one could say up, down, and all that don't even really matter at that point now, huh?
Oh, down is towards the direction of
the center of the Earth is down, and going out of the globe is basically up. Yes. Is which I got you.
But gravity can show the things. Yes, they literally can fall sideways, because you can use a torsion bar balance to make things move sideways using only an attraction due to gravity, right? And it's not just things on Earth. The law of universal gravity can help us predict, okay? This might be a bit outside of the wheelhouse of the conversation, but do you know how we discovered Neptune?
Oh wow, man. If you really want me to share with you what made me become a flat earther, I would love to, because I got a couple of arguments to share with you what I couldn't debunk. And if you can, but you can go ahead though. I'm gonna mute up and you can go ahead and tell me about Neptune. Go ahead.
Right. So Neptune was an excellent way to demonstrate the law of universal gravitational attraction and our understanding of Kepler's planetary motions, right?
Okay.
So we were looking at the orbit of Uranus, right? And we could see that during a particular part of the year, during the particular part of Uranus's orbit, as it went through the sky and you could track it, it did something weird, right? There's something that Newton's laws couldn't explain. There was a slight perturbation to the orbit. It wobbled in a way that didn't make sense based on what we understood and the observations that we had. So they had a little think and they said, well, based on Newton's laws, right, that wobble can be explained if there is another planet at a certain position, right? If we apply Newton's laws of universal gravitational attraction and Kepler's planetary motions, we can actually say that there should be a planetary body with a certain mass at this spot in the sky. No one's ever seen it before, right? This is a complete guess just based on universal law of gravitational attraction and what we understand about orbits, right? So they had a guess and they said, right, so if we look at this point in the sky at this particular time, we should find a new planet. And lo and behold, they looked in the sky at that point. At that time, that Newton's universal law of gravitational attraction told them to look, and they found Neptune where they expected it to be. And that was purely 100% because of Newton's universal law of gravitational attraction and the predictions that it allows us to make.
Well, the ancestors had charted out all the stars thousands of years ago before science. This is a fact. This is a fact that we got zodiac wheels that are older than Galileo, Plato, Isaac Newton, and all them. And let's talk about that before I move forward, because I'm screen sharing a lot of stuff, and I'm just skipping around collecting information for future debate. So check this out, right? On a flat, hold on.
What do you say about it with Neptune, though? Before we move on, what do you say about that?
I say nothing. I say nothing about it because I just want to move forward. But I appreciate you for sharing that, and I will be. I'm collecting information. That's all. I know we don't have a lot of time.
Gravity is a thing, as we say.
Say what now?
It's an excellent demonstration that gravity is a thing, as we say.
I understand what they teach you, everything you explain. I'm perfectly familiar with it, man. I didn't come here to really learn about Neptune. I don't think it proves gravity at all, man. And I just don't want to spend my time. I just don't want to spend my time dealing with Neptune. I want to talk about the ground I'm walking on and what it's shaped like. Real quick, I want to I want to always keep us back on the meat of the debate, because it just say you're right or wrong about Neptune, I'ma still be a flat earther. Now, when you go to dealing with the arguments that I have that led me into flat earth, it wasn't Neptune. It wasn't their discovery on Neptune. What led me into flat earth, if you're allowing me to share those arguments with you, which you haven't, I'm trying, but if you allow me to share those arguments with you and deal with the arguments that made me a flat earther, every flat earther saw something different that made them say, hey, I'm ditching the globe. And I think what globalists should do is say, okay, what led you to your silly flat earth argument?
I do like to do that.
Share the arguments with me that specifically made you say the globe is wrong, and you go to each one of them. You know what I'm saying? And I think that's a good start. But yeah, I got a question for you.
Yeah, please do.
I'm definitely into the zodiac wheel and astrology, which is something that the ancestors introduced us to as well, way before the guys you mentioned here. But anyway, that's a different thing.
Didn't we recently add an extra zodiac? Because it's changed position.
I would like to ask here again. I just want to share the
Yeah, yeah.
arguments with you there. So the thing is this right here. On a globe, I want to know, do people, we're going to make a little imaginary equator where my mouse is. I want to know, do people that's on the bottom of this globe who are falling up, as you say, because you know people on the sides are falling sideways. Let's talk about the people that's falling up right here on the bottom, right below the equator right there, right?
Falling up? I mean, not for them, they're not.
Well, they're falling toward the center of a globe earth and their feet is on the surface. So to the people up here, they will be falling up, and to the people up here, that we know is reverse. We understand that. We ain't gonna stop.
Yeah, yeah. Obviously, directions.
But here, right. We got you. We both know that. So the thing is this right here. The people at the bottom here, when they look up, they're looking where my mouse is going. Can you see my mouse's cursor?
No, when they look up, they'd be looking on this picture. If they look up, they'd be looking in this picture straight down. Yes.
Right. Thank you. So, and the people here will be looking straight up. Got you. So would they see a different set of constellations down here than up here? Would the people up here at the top of the globe look up and see a different set of stars than the people down here at the bottom?
Yes, they do. Yeah, they
okay.
100%.
Got you. That's just an easy question. I'm walking my way into the big question. Now we have one zodiac wheel that people at the so-called bottom and top of the globe has shared for centuries, and I have a quick question with you that I'm about to lead to based on this zodiac wheel that we all share. Just say we live on a globe, right? Now check this out. This zodiac wheel was really designed to be placed over a flat earth and see where our sky was said to be like a carousel in the park with all the animals you see going around the carousel. All of those animals represent the zodiac going. This is the whole history of the carousel. We both giving little history things. But yeah, it's based upon the whole flat earth. The ancients saw the earth as a torus field. Go look it up, guys. And that all of the luminaries are in a circuit around Polaris, which is why we see the sun and moon in the sky at the same time, which is something I'm going to ask you about after I deal with this zodiac thing. So if I put the zodiac wheel above the flat earth, it makes perfect sense how everybody living on a flat earth could share one wheel no matter what side you own, right? It makes perfect sense that it's a wheel. It's like a car that's rolling on a wheel versus a car rolling on a spherical tire. I don't know, but the thing, you get it, is one wheel. So the thing here for the globe earth, what I would say, people at the top of this earth would have a zodiac wheel up here. They would look up, and the zodiac wheel would be based upon the stars that they look up and see. And the people down here would have to have a different zodiac wheel because you just said they got a set of different stars and constellations. So why are they still using the same wheel as the people at the top? Why they don't have a wheel to represent a whole nother set of constellations that we see at the bottom?
Honest answer, I mean, the honest answer is because, zodiacs and stuff is complete and utter nonsense. But where the zodiac came from is important, right? Do you know?
But I'm just saying, when you say that.
Wait. Let me ask a question. Do you know where that zodiac wheel came from?
I just told you that
you said the ancients. Who in particular came up with that zodiac wheel?
No one person came up with the zodiac wheel. Listen to me. Every ancient civilization had their own interpretation of those constellations, but they all put it on one wheel, just like we see here. Whether you use a Babylonian, a Vedic, or whatever, your sign may be different in China. You may be a rat or something like that, but they're still referring to the same constellations.
Yeah,
that's all I'm saying.
The zodiac that is general in Western civilization that's used is based on the sky in one position on Earth, not on the position of sky, the position of stuff in the sky everywhere. And that's just it. It's just spread, right? But the zodiac itself is an issue for flat Earth because we had to add an extra zodiac sign because of the change in position of the stars.
Listen, you're talking about. Hold on, wait.
That's just an important point.
Wait a
minute.
minute.
Know that the stars change position.
Here's what I don't know that, and I don't think you do either.
I mean, they're measured to change, but they're literally measured to change position. I can show
that's what they said. But do you own a telescope? I got a good one. So I do own a telescope.
And
wait a minute.
Here's the thing.
We've been making the same predictions in the heavens for over thousands of years, spot on to the T, based on a Vedic system. So talking about their changing, you're saying that they're changing so little by thousands of years that it's almost immeasurable. And I just disagree with that. That's like a easy, convenient argument to have, because you will have to prove that they change. But you're saying, yeah, they change, but it's sort of like the evolution argument. It's happening so small over time, you know. So, but hold on, wait a minute. Wait. I gotta ask you something. Again, proving that ain't gonna make me. If you address the argument that I want you to address about the people down here not having their own zodiac wheel, that'll lead me out of the flat Earth. You gotta address what I need you to address. What led me out the flat Earth? Remember, whatever you talking about now. When you're done with that, I'ma still be a flat earther. But if you can debunk and address what I'm showing here, I'll leave the flat Earth. Is what I'm saying. So I'm trying to point you to the things that I'm baffled with, and not where you're trying to go.
Let me get to that. So that particular zodiac wheel is Babylonian, right? That one that you're showing there.
Which one you want? I'll pull up the one you want. Which one you want?
Oh no, the one that you're showing. I'm talking about the one that you're showing.
Yeah, but which one you want me to show?
Wait. Let me finish. The Babylonian zodiac wheel is where they all came from and where they all changed their own interpretations from. However, China came up with their own signs independently, very different, based on different constellations to people in other places. The Babylonians were closer to the equator. The Chinese were a lot higher. They used different constellations to map out their own personal signs. But the change in position of the stars means that the zodiacs do not correspond to what they always have. And the stars do change position. This has been recorded by sailors over centuries, because if we didn't record the change in position of the stars, we would not be able to use the stars to navigate accurately. You can go to mctoon.net/Polaris and see nautical almanacs throughout the centuries where sailors have literally charted the change in position of stars, meaning that the zodiacs were never accurate. What they based the signs on for
that's bull crap.
They haven't been accurate. It's not on. This is the truth. You can literally go and look at the change in position of the stars throughout the centuries.
Okay. I got you. But back to the meat at hand. On a globe, shouldn't the people at the bottom have a different will than the people at the top, though? No matter how you want to say it changed. Yeah,
it's like a cult thing.
Say what?
I mean, the zodiac isn't something that is based on science or
wait a minute. Here's what I'm saying. Here's what I'm saying. Hold on. I got you. It ain't based on science, but here's my point of why you got to hear the argument that I heard from flat earthers that made me say, I can't debunk that. You can't just say it's not based on science. Here's the argument. This is scientific, that on a globe, there's an equator line right here, and everybody above this line will look up and see a completely different sky than the people at the bottom. My question is, if that's true that we've been living on a globe for all that time, why is it there another wheel for the people on the bottom to show this other sky, and these wheels would spin, one would spin clockwise, one would spin counterclockwise? Because wait a minute, wait. You can't answer me if you cut me off, and it's definitely not going to help me with my baffled arguments with this flat earth thing. I'm really being a student now, and I want to learn. I was taught that at the top of the globe, there's a Coriolis effect. Below this line, things spin opposite directions, counterclockwise and clockwise. These two wheels should be on each side. When the people up here look up at the sky, their sky should spin a certain way, and the people should look down at the bottom should have a totally different sky that spin opposite. I'm saying, where is the opposite wheel? Like a hamburger with two buns. Where is the other bun? That's all I want.
Yeah,
okay, why didn't the people at the bottom? Well, why didn't they make two wheels for these two? Wait a minute. I got you. You have two different skies. Why wouldn't you map them both out? You have the in perspective to the globe. Everything above represents a whole different part of the universe that you need to chart than the people at the bottom studying the bottom part of the universe, or below the equator. These are different. We wouldn't just look in one direction in a multi-directional universe, and what we would see in each direction would be different.
Yeah. So again, they didn't bother doing it because people went, look, here's the zodiac wheel, you use this, it tells you what your sign is, and they never bothered to make anything.
You're dealing with astrology, and I'm dealing with astronomy. You're mixing it up.
Yeah, no, I'm not. I'm talking about the zodiac, like the wheel that you're on about, okay? Which is based on the position of the stars. It's only based on the position of stars from one position, right? And what happened was that the people that came up with that then spread everywhere and went, look, here's this zodiac wheel. You use this tells you what your sign is. Doesn't matter what that says up there.
No, but wait a minute. Don't you think the people at the bottom of the earth would have been making it? Wait a minute. Okay, man, you're not answering me though. It's not helping, teacher.
I'm trying to answer you. If you just let me finish what I'm trying to say.
Okay,
please.
I'm sorry. Go ahead.
Right. So again, the people whenever they got the zodiac, they just followed what they were told, and they didn't want to make their own one because it was already there.
What's your sources on that?
The fact that it came from the Babylonians and spread out across the cultures.
Okay, I got you. Now, let me ask you a question. To me, that makes no sense. No, I heard you. I got you. I got you.
Quite finished, right?
No, but I understand. You answer me to satisfaction. I completely got it. I get it now, and I would like to ask you another question just for the sake. Okay. I got so many questions than time. That's the reason I'm trying to do this. You've been really giving me way more than what I need on the answer side, and it's really not allowing me to knock off all these questions on my list. I'm stuck at the top. So check this out, right? I don't understand why the people at the bottom of this globe will wait on someone else to map their sky, then they will bring their star maps to them. That would be like saying, yeah, we all agree that we see the Big Dipper, but we don't. Like, not everybody on the globe should look up and see the Big Dipper in the sky. But everyone, like you said, share this same sky map that the Babylonians gave. That'll be like someone else giving me a map of their city. Someone else saying, look, I mapped out my city. Hey, everybody use the map of my city. Wouldn't everyone else map out their own sky and their own cities as well? Like, everyone wasn't so dependent on the Babylonians. I think that at the same time, hold on, I'm not done. I'm almost done here. I'm almost done. I think at the same time, people would have been mapping up their sky here. People would have been mapping their sky down here as well. And over here, they want to wait on a certain group. I think that was a horrible answer.
Okay, so not everyone came up with the zodiac because not everyone thought that the position of the stars were related to how their lives work. When the Babylonians came up with the original zodiac wheel, okay, they were just north of the equator, very close to the equator, right? So for people in the southern hemisphere, they do see the same evening constellation. And thank you for Secret G pointing this out. They see the same evening constellations of the zodiac that we do in the northern hemisphere, but they just appear higher in the sky instead of close to the horizon. So the constellations that the zodiac use can generally be seen pretty much wherever you are on the earth, unless you're like really extremely close to the poles, which is when the zodiac tends to fall apart, because the zodiac itself was based on the stars that the Babylonians could see and the positions of the stars that the Babylonians can see.
Let me clarify something. I don't understand what you said.
the position of the stars that the Babylonians used to make their chart of the zodiac was very close to the horizon at the equator.
Can you clarify?
When the people in the south got that zodiac wheel, their constellations of the zodiac were the same, but they just appeared higher in the sky.
I got you. Can you clarify something based on that? Okay, so this is what I'm having problems with based on that. You're telling me that the people that's looking up right here at the bottom of the globe, that's looking up, now they're looking at a whole nother basically universe down there, right? Than the people that's looking up on above the equator who looking up at a whole nother different universe, right? You're telling me that's all wrong, that the people that's looking up down here actually can see what the people at the top see, but it's just up higher in the sky. I'm trying to see how they vision can wrap around.
That's why you'll find that the further south you go, and this is something in Argentina especially that you can notice, the further south you go, the less people follow zodiacs. It's an interesting thing that you'll find. All right.
Actually, there some of the best zodiacs come from those areas. Some of the best. So I find it, yeah, but that's crazy. That's an opinion. That's an opinion. That's definitely an opinion, though.
But it's kind of a census thing that you can look up yourself. Right?
Well, I don't think they went around and asked everybody who followed the zodiac. You know, that's crazy.
Like I said, the reason why they didn't change the zodiac wheel because most people realize that it doesn't.
I understand your answer, but I have another question.
It's not important to the shape of the Earth, right?
Can
I show you one thing that it happened very recently, which I'm pretty sure kills the flat Earth dead.
I tell you what,
I love your opinion.
If you don't want to deal with the arguments that led me away from the globe, it's not really going to help me in my journey to see if what I'm believing in is true or not.
We just done one of your arguments, but I would now like to show you one of my arguments.
I wasn't really even able to really show you anything here.
Honestly,
okay. Well, I tell you what, I'm gonna stop my screen share. I'm going to stop my screen share and you can share something with me. But I want to ask you one more question just for clarity, and I'll shut this off.
Go ahead.
Now, if you can see my mouse pointer, because my mind is baffled and you're not taking your time with me on the things that I'm most confused about, which is kind of annoying to me. But I'm going to ask you this and I'll move on. It's like you're running from the things I'm most baffled about. That's strange. But here's what I'm here's what I'm most baffled about. Below this equator line, when people look up, they're not looking at the same sky as the people who looking up above the line. These are different parts of the universe is basically split at Earth equator, because up to these people here is different than up to these people here. And I'm saying if they're looking up where my mouse is going down, they're looking up, which would be, you know, what my mouse is going down, how we looking at this image, and they would see, you know, from this perspective, a whole nother universal sky full of stars than the people here. What I'm baffled about is how they still can see all of these other stars and some of the people's stars at the top, but it's just higher in the sky. I'm not understanding that part, how they can, I'm lost there. Like,
not understanding it is kind of, I mean, I can't help you understand it.
Yes, you can. I think you're a great teacher. I believe in you. Go ahead, try.
Celestial sphere of stars around us, right? And the zodiac constellations specifically are found in a ring along the celestial equator, right? So the same argument can be made for why the people further north didn't have their own zodiac wheel. It's simple, because the people that came up with the zodiac spread it, and they said, oh, look, you can still kind of see those stars. They're just in a slightly different position. And that's it. All right.
I get what you're saying, but you're not answering me why they can still see those stars if they're looking at a whole nother universe down there. That's the part I don't get.
You're still going to be able to see some of the stars, aren't you?
I don't understand how they would. I don't understand how a dude standing where my mouse at looking directly up can see something that a dude standing down here looking directly up. Well, I don't see how they should see opposite. Okay.
They do see opposite. That's the thing. They do see opposite stars. And if you're standing at the North Pole looking up, you see all the stars circling around Polaris. And then every 69.1 miles.
Now Polaris is the North Star, right?
Wait. Yeah, Polaris and North.
What about the South Star?
At the North Pole, let me finish. At the North Pole, all right, Polaris will be exactly 90 degrees above you. It will be your zenith. Okay?
I got you.
However, for
what about
every
the South Pole?
Let me finish. For every 69.1 miles that you move away from the North Pole, the position of Polaris in the sky drops by 1 degree until you get to the equator, where Polaris is on the horizon. And then if you move further south of the equator, you can no longer see Polaris. However, if you're at the South Pole, let me finish. If you're at the South Pole, looking directly up, which on this picture would be down, you will see stars rotating around the southern point of rotation. There isn't a star there. There's just a void where the stars rotate around it. And that point, for every 69.1 miles that you move away from the South Pole, will drop in the sky by 1 degree until you get to the equator, where that star will be on the horizon and then disappear. So you see the stars that you are supposed to see based on the angle of latitude that you're at. So 90 degrees at the North Pole, exactly up. I
just don't see,
or every 60 nautical miles, 1 degree.
Yeah, I see, but the zodiac wheel I showed is based upon the constellations going around the North Star. But there's not one. Hold up, but there's not a zodiac wheel based upon the South Hole. Okay, you're not. I'm not even finished with
what you just said.
You know what? I'm gonna stop my screen share, man. You're not even letting me. Yeah,
I am. I just want to. You said that the zodiac wheel is based around the stars around the North Pole, but it's not. It's based around stars around the equator, a celestial ring around the equator.
No, exactly. It's not. It's definitely based. You just said that the stars rotate around Polaris. You just said that, and I asked you in the South, do they rotate around the Southern Star? You said no, it's not a star. It's a void they rotate around. How can you say? Yes. Oh, wait a minute. The stars are the constellations. So if the stars rotate around Polaris, then the constellations rotate around Polaris, and the constellations is literally what the zodiac wheel is.
Yeah, but the constellations that you see on the zodiac wheel are based on a celestial ring around the equator, which can be seen from the north or south.
Right? But that's the point. Remember though, the question was, should there be 2 different wheels to split up what the 2 different skies will see at that equator line? And I guess the answer is no. On a globe, both sides can use the same wheel, and I just don't still see how that'll work, but I'm going to move on. I have one more question in my screen share.
The main reason we can both, north and south use it is because it's based on a ring of stars around the celestial equator.
I got you.
But in my opinion, in general, how, we try and show that the Earth is a globe or not, the zodiac signs are completely irrelevant because they're not accurate to what we see in the world, which is why we have to.
I understand what they.
So I want to show you something which is based in actual reality. All right. Yeah, and I'd love to get you.
Can we talk about the equator real quick? Because that was my next question in the screen share after you're done. Go ahead.
Do you want to do the equator thing first, or can I go through my thing that I want to talk about first?
It don't matter. However you want to do. However you want to do it.
So, very recently, a really, really big volcanic eruption happened in some islands around Tonga, right? Literally devastated this island. And unfortunately for the flat Earth, it presents a bit of a problem because such a large explosion allows us to register pressure waves, all right? So, let me turn off the audio. So, huge eruption, tsunami hits Tonga after underwater volcanic eruption. Now, the eruption, I'm sure you're aware, could be seen from space. Have you seen the eruption in the news?
I have not.
All right, let me show you the eruption from space before we get into this analysis.
Okay, from space. All right. Hey, do you remember when Nixon made a call to space on a landline phone when he called the moon?
He didn't use a landline.
Yes, he did, man. He used the rotor. Come on, bro.
He used a phone that was connected to radios.
That was a damn long radio transmission. Yo, when I go through the mountains, when I go through the mountains, my song gets static. The moon transmissions was clear as hell. And when I go through the mountains, my song got static, and we got newer technology what they had then. That's another debate, though. I'm just talking to you while you look for your stuff.
So this was taken with some satellites, and you can see the eruption. Come on. You can see it there, and here's a better version of it. You can see the eruption happening, and it's satellites from space. Oh, I'm not even showing it on my screen. My bad.
Oh, man.
Sorry.
I'm showing the wrong screen. You know what?
Right, here we go. Here's seeing the eruption from space. So this is what happened, and it caused quite a lot of devastation, even some
how many
tsunami.
miles up the space began and Earth ends?
Okay, we can get to that afterwards. After my point, that's
yeah, but you keep saying from space. I want to verify from space. Exactly,
really,
where is this space?
High up. Really, really high up. That's all that matters.
Yeah,
right
really,
now.
really high. Wow, I'm laughing. Go ahead, you got it.
We can get to the specifics another time, right? I just want to go through the actual the details of what's going on, right? So that massive explosion, because it was so big, we were able to actually detect the explosion all around the world. And what you're seeing here is different barometric stations around the world that are registering that pressure wave, okay? The interesting thing is that we can actually plot out where these happen. So here is a bunch of observations. And thank you very much to Science in It Out for doing this video. And what he did was he took the times that the pressure wave got to him, got to these stations, right, and plotted out the times on a flat Earth, right? So this is the most standard flat Earth map that we see. So what he did was he plotted out the explosion was where it's red, and it gets yellow and then green and then blue for furthest, for most time after the explosion they registered the pressure wave. And when we look at the points plotted out on a flat Earth, none of them make sense. For instance, the pressure wave got North America and South America at the same time. The pressure wave managed to hit all sides of Africa simultaneously. The pressure wave managed to reach points in Australia that were further away before they should have. And none of it actually matches up with what we should expect to see if the Earth is flat. But
what should we see if the Earth is flat? Tell me that, since you know.
I've just shown you here. If the Earth was flat, each of these stations would have received the pressure wave, at times according to their distance away from when it happened. But the times didn't match, right?
I'm gonna be honest with you, man. I'm gonna be straight up.
Let me finish. North and South America received the pressure wave at the same time, even though on this map, South America is a lot further away from the pressure wave, okay? But if you map out where the pressure waves hit on a globe, it starts to make sense, because the pressure wave would travel out in concentric circles, all right? And that's what happened for the center.
Now here's what I need to understand.
Let me finish. Let me finish, please. The center there, where it's red, is where the explosion happened, and then orange, yellow, it gets further away. And if you map out the times that the pressure wave hit these barometric stations, it matches with what you would expect on a globe. So it hit one side of Australia before the other, and then it went to, the other side of the planet, or the furthest amount of time away. So it took the longest amount of time to go to what would be the antipodal point. And there were certain stations that managed to receive it twice, because they weren't exactly on the antipodal, and they received it once, and then they received it again when it traveled around the entire world. So all of these barometric stations across the entire planet showed that as the pressure wave travel through, along the distance, along the sphere of the Earth,
you're saying, man.
The things that are further away took the longest for the pressure wave to reach them. But if it was the flat Earth, then none of the measurements of when the pressure waves reach the countries make any sense at all. So flat Earth needs to explain how the pressure waves reach these certain positions when they did. Like I said, South and North America
and I'll check
and Hong Kong received the pressure wave at the same time.
If you're giving me a homework assignment, I will accept the challenge all day. I would definitely explain the pressure points. Now, in my opinion, I don't think that's going to prove flat or globe Earth, but I also think that the technology used to chart these pressure points is impossible to use unless you're on a flat Earth, just like radar, which is a line scanning a perfect circle and not a sphere. See what I'm saying? It's the same kind of concept. But listen, wait. I just let you talk for a while. You got to share the mic a little bit, just a little.
I just want to clarify that the technology was simply barometric readings.
I know you want to clarify, but I don't think it proves a globe at all. I think it's a lot of lengthy stuff, and not at all. So, but listen, if you're making a challenge, if you're telling me to pointing me in that direction to explain the science on flat Earth, I'm up for the challenge. Cool. All right. I'm not interested in that at the moment, but I will go back to this video, look it up, look at this experiment, and go deep into it.
Just for me,
all right.
is
okay.
One of the things that shows the Earth cannot be flat. Listen.
I get it. You don't have to tell me that. I understand that you definitely think the Earth is a globe based on your hypothesis there. If I could speak though, please.
Yeah, go ahead.
I got you. I don't know what you want me to do with that right now. I'm glad you shared it with me. Now I know there's another argument I need to go and look into. I'm not going to do open research here and start charting it right here that'll take up, come on, I would like to move forward. You made your argument, so I'm gonna move forward. I'll look into that and do the homework that you told me to do. I owe you that. So sure. Here, okay, now I'm gonna send me all of that. Send me that along with the other one. All right, because I'm definitely gonna look into it. I'm not just talking. I'm definitely gonna do the homework. Let's go ahead and go to some of the stuff that I want to share with you real quick. And thank you for sharing that. Thank you for sharing that. All right, let me go ahead and go here for a minute, and I'm gonna play this video. This is my video, so you have no problem with copyright strikes or nothing like that. So let's go ahead. What I want, this next thing I want to talk to you about is seeing the sun and moon in the sky at the same time. Was something I have a problem with, which kind of led me into the flat Earth.
See the sun and the moon in the sky at the same time.
Right, like this video showing here. So I was saying to myself, to see the sun and moon in the sky at the same time, and I'm gonna pause that a minute, and I'm gonna try to see if I can find. Like a sort of example, because when I think about the sun and the moon at the sky at the same time, right now, when it come to the flat Earth, let me go ahead and grab this next image. It's a couple of things I'm gonna have to grab with this. All right, I got so many folders open. So what I'm showing on the screen now is how, if I'm picturing me going outside on a globe, right? Looking up in the sky and seeing the sun and moon in the sky at the same time. To me, this is kind of like what I'm picturing in my mind. And that would make perfect sense to me. But the only thing about it would be the people on the other side of the globe, I would kind of wonder, like, they would have no sun and moon in their sky. But I thought about it. I said, one day I was live, and there was brothers that was on the southern so-called hemisphere of the globe, and there were brothers, on this part of the earth, and we all were filming the sun and moon in the sky at the same time. And we all thought that that was great proof for the flat earth. So I'm going to share something else for you and see if you can tell us where we're wrong at.
Yeah. I mean,
Hold
I'm
on.
confused as to why this would be an issue for the
Okay,
globe.
no doubt. No doubt. I'm going to show you why. See, when the ancients, how they conceived the earth, explain why we can see the sun and moon out at the same time every day. This is every single day. I make sure I make it my business to go look at it.
You
And
can't see the moon every day at the same time.
well, of course, there's some atmospheric conditions some days where it shouldn't be hidden from you, of course. But they're always so my thing is this right here though. On a flat earth, it explains how everyone on the circle of the earth could go outside no matter where they are and all look up and see the sun and moon on each side, just like we did on that live stream with my brothers from across the world. It wouldn't explain how that would be possible on a globe where in the center of the system you got the sun and then the moon would only be seen next to the sun during a certain rotation. So the moon will have to, for example, it'll have to circle the earth at a certain angle where it's on the sun side, and only those people over there would see the sun and moon in the sky at the same time, and that would be an eclipse every day, basically. But the moon will have to swing right on the side of the sun, and then it'll go back to the part of the earth that's where the earth is in between the sun and the moon. And then it'll swing back around, and now the moon is in between the earth and the sun. They call that an eclipse, though. We don't see eclipses every day. But what we do see is the sun and moon out. For the most part, granted atmospheric conditions are right, we can see them out every day on clear days, just like we done here. And like I make it my business to do every day here in Nevada, where the atmospheric conditions are perfect for it. So I always thought that if I can go outside, look to each of my shoulders, see the sun and moon out at the same time, that was kind of damnable evidence for the globe. Can you explain to me, other than what I'm showing on the screen here, how would that be possible on a globe and we not have more eclipses?
Mainly the sun and the moon are extremely far away, so they're not
Right.
going to be as close to the earth as to make that an issue. But also I 100% disagree with you that the sun and the moon are in the sky at the same time every day. That just does not happen every day.
You should go outside more.
Yeah, I go outside quite a lot in Scotland. I've got very, very good views of the moon, and you cannot absolutely 100% see the sun and the moon in the sky at the same time.
Only way you can't is like atmospheric condition. For the most part, for the most part. But go ahead. I ain't gonna debate you on that. But you shouldn't see them in the sky at all, for real, unless it's an eclipse or something like that. If we were on a globe, when you agree.
Well, no, there's plenty of times that you can see them both because they're really, really far away. So they're
okay.
The angle, the field of view that you've got to be able to view them is extremely large.
Okay, well, I got another question.
I've actually got a solar system program that I could show you.
But wait a minute, no, because you're gonna change my screen share. You keep doing that, and it takes me off. Well, I'm trying to ask you something. Check this out. I need you to deal with the experiment that I did, not programming. I need you to deal. Hold on. The experiment was I had a live stream with a bunch of people on all the sides of the earth at the same time, and we all were filming the sun and moon in the sky. On a globe, if you got one, just say you got people on this side that say, hey, we can see the sun and moon in the sky. How can people on this side also see the sun and moon in the sky too, is what I'm asking you.
Because the sun and the moon are really, really, really far away.
Oh my God.
The field of view is extremely large. But here's the question. Did you compare what you guys saw with what you would expect on the globe. What did you do to make that comparison?
Well, I was taught that on a globe, simple, night and day. On one side of the globe, the sun is giving somebody's night, and on the other side of the globe, the sun is giving somebody daytime, sun and moon. And the only time that the moon will go in front of the sun, we call it a eclipse, which is what I'm gonna pull a picture of an eclipse is, so I can ask you. Hold on. So what I'm saying is that when the moon passes in front of the sun, you know, we'll call it an eclipse or whatever. So my thing is, that's the only way you can see the sun and moon in the sky at the same time on a globe. I'm gonna just use this image for example though. Like, for example, this moon here will have to be at a certain orbit to where it's near the sun, where it has caught up to the sun. And only people in this side of the world will see that eclipse, and that's how eclipses happen. Everybody can't see them. So that's how I was taught as a globalist. You know, I don't know if you want to correct my teachers, but check this out. The thing is,
I can't talk about what you were taught. You know, I've no idea
cool. I'll just ask the question and make it brief then. So what just to conclude this, the only way I'm saying that you can see the sun and moon in the sky at the same time on a globe is that would be during eclipses. We see them in the sky at the same time on a flat earth, and it's not an eclipse, which is what I was showing with the video footage. And more, and then to go further, you got people in different hemispheres seeing them at the same time, and I don't think you answered that to satisfaction.
Okay, so let's answer it to satisfaction then. What was the time and date of your observation? And let's compare it to what we should see.
I can't remember offhand, but I'll give you that information just like you're going to give me the information. I'm going to give you that.
Oh, well, I mean, I could show you right now what we expect to see and compare it with that. My answer is exactly what we expect to see. You know, what we see with the moon and the sun in the sky at the same time matches the globe predictions, which is why I specifically asked you for the time and observations so that I can compare it against reality.
I saw the sun and moon in the sky at the same time today. I want to say toward the morning time, early morning, I still had the moon in the sky, and I had the sun peeking over the horizon. So the same concept of you, even at nighttime, if you stay outside long enough and stay up during dawn, you'll have a bright white moon above you, but you'll look over at the horizon line and see the day coming in with the sun bright peeking over that horizon line. You know what I'm saying? And you can look and see the moon and the sun even at nighttime, not just during the day like this video. Now, I don't know what time this video was right here. Yeah, but
let's just compare it to today and check what you're saying. So you saw it today in the sky. Right. I have to switch my screens backwards. It's really confusing.
Now, if you go outside, for the most part, you can see it almost every day, the sun and moon in the sky at the same time.
Right. So did you do your GMT plus -7, aren't you? So let's go GMT -7. What time was it? You could see the sun and the moon in the sky at the same time?
Let's say at dawn, you can see them in the sky at the same time all the time. So just deal with dawn.
What time was dawn for you?
Dawn for me is anywhere between 3 a.m. to like 5 or 6 a.m., maybe 2 a.m. to 6 a.m. to cover it roughly. I'm not sure, but somewhere in that time.
All right, so let's go in and have a look at
Matter of
Earth.
fact, let me be accurate with you.
And we want night sky. And your Pacific, which is over here. Is that about where you would say you are?
Yeah. Yeah.
Okay. All right. Let's let it play so we can. Oh, that's going way too fast. Oh. Oh God, sorry. The app is being weird. We're gonna, so today is the 7, no, what is today? We're January 17th. In your position, we'll take that back a bit. So let's just get, just as we hit dawn. There we go. Take it back a little bit.
Oh, man.
Right. And then we can have a look and see if the sun and the moon are where we're supposed to see them. So we'll have a look at the sun. So is the sun in the sky there? Matches what we're supposed to see. And could we also see the moon? Let's have a look. All right, so at that time, the moon would have been just below the horizon. So you're telling me that today you saw the sun and the moon in the sky at the same time?
Damn near every day I see them at the same time.
Let's take that back and let's have a look. So the moon was in the sky, let's say the latest at about 7:19 a.m. Could we also see the sun about that time? The sun first appeared. Right, so that's when the sun first appeared, was right there. Let's say 7:51. And let's look for the moon. All right, it looks like the sun and the moon would have literally both been on the horizon at about the same time, which matches what we expect.
What time would that would have been on your program?
This is 7:51 a.m. roughly in your location, and both the
That's
sun
about right.
and the moon would have been.
Well, that was definitely during the time frame that I just gave you, so I don't see what's the problem.
Well, neither do I really. I mean, the sun and there's hills there, obviously, but that would be where the horizon was.
Now listen. Now,
so both the sun and the moon were visible in the sky at the same time.
Gotcha.
In about 7:40 and
all right.
8.
Now, how is that possible on a globe? How can the sun and moon be both visible in the sky at any time on a globe? And it's not an eclipse. And it's not an eclipse.
I'll show you right now. We go back out to the planetary system.
Because that whole system is based on flat Earth. You got to think about this, right? And I want you to just take a look at my screen share real quick. And it's gonna take like 15 seconds while I asked you that. And you can
answer the question. You said, how could the sun and the moon be seen at the same time? Well, let's go
ahead, and I'm going to show you why I asked you that.
Right, so here we have, oh, I just went off of Earth. E-A-R-T-H. Ooh, that's not how you spell Earth, Craig. E-A-R-T-H. Right. So let's zoom in to Earth. And you are, where's America? Right, there's North America. So from this point, right,
Hold
round
on,
about
my
here,
bad, my bad. I need to be sharing your stuff with my people too. I keep forgetting about my people. Sorry about that, y'all. Please forgive me. Hold
okay,
on.
right. So,
They need to be able to see what you're doing too. Go ahead. Go ahead. You got it.
so this is what it would look like from space at the time that you've just said this morning, okay? And you're over here, right, on the Pacific coast. And as you can see, if you were looking there, you'd be able to see the moon, right? But you would also be able to see the sun from that same position.
Now keep it froze right there. Keep it froze right there. Now let's zoom in on the Earth. Now you moved it. You moved that position. You moved that position. I got a question. Show me the position where, from my perspective, I'm gonna see the sun and moon at the same time, and then freeze it there. No, from the globe view. From the globe view. From the globe.
I mean, it's very hard to. Well, you want to see it from the outside.
You just did it. Do what you just did again from the globe view. I like what you're doing from the outside globe view. Let's play with that some more. Yeah, don't get troubleshoot with me now. You see where I'm about to go. You see? Yeah.
There we go.
All right, let's go back to the Earth. Yeah. Let's play with that. Let's go. Let's keep this up. I like this view. Let's deal with it.
So where are we? So here we go.
Now, can you bring that magic angle back that you just gave me a minute ago?
There we go. That's what we're looking at. So we've got the moon viewed that angle, right? So you'll be here looking over at the moon, right? But then imagine you're still on the surface there.
I got you.
Right. So that surface is looking out over here now, still on the same surface, and the sun there. Just
I got
on the
you.
horizon.
Keep it there. Now keep it paused there. Cause keep it at that angle, just right there. Freeze it right there. No. What? Now, see you moving it again.
Right, there we go. That's what it was. Sorry.
All right, cool. Because I already know where the moon that is in my top left corner over there, like where the scope sign at. So you're right. From that angle, I will look to my right, like where that near the scope sign at, and see the moon. And then I will look over to the left and see the sun. Now, from this program is dope because check it out. That explains my location looking up, seeing the sun and moon. However, it wouldn't explain how the people directly behind us, where we see the dark side of the earth that back here, they would look up and see nothing in the sky. But I did an experiment where we all looked up and saw the sun and moon at the same time, and everybody just can't do it on a globe.
Well, like I said, if you could get me all of those locations and times.
I got you. Okay.
We could check it against what the model says.
I will.
Right?
Well, cool. I won't make that argument to in the future. Then let me ask you another question.
Today it matches the observation of the globe.
I got you.
Saw, right?
Quick question. What about, like, for example, the angle you got here? What would the people in the back see when they look up back there in the back? They will see nothing. Here. They will see nothing in the sky. Yeah. For example, when they look up, they will see nothing. Right?
What's that? Is that the Big Dipper there? Is that Aquarius? I think. So I mean, they'd be looking off to this way. They'd probably just catch a glimpse of the moon, but obviously, the sun is dark here because the sun's the other side. But what we can do is we can zoom out and go away. We can play it to see what happens with the positions and where it all goes.
Let's do it.
Well, this is only useful if you give me the times and dates that the observations are on. Because
I'm gonna do that.
This is an accurate model of what the heliocentric says the model is. This maps out the celestial sphere of all the stars, the position of over 15,000 bodies in the solar system, and for every single observation that I've ever checked, it always.
I want to know how the Vedics were able to make the same predictions and have the same accuracy, and they were flat earthers, though.
They didn't have the same accuracy.
Yes, they did. But
when you look at the ancient predictions for eclipse, things like that.
Listen, hold on. Wait a minute. You're not letting me speak. I'm making a claim. You got to at least let me give arguments for the claim. So the claim, here's the thing. The ancient Mayans predicted the 2017 alignment thousands of years before it happened. They knew how the sky was going to be in our time. And they were flat earthers. They listen, wait a minute. They predicted the alignment in 2017, the great alignment that happened.
Did you say the Mayans?
Yes, and it was all on a History Channel. Everybody was talking about it.
In 2012.
Say that again.
The Mayans predicted the entire Earth would end in 2012.
No, they did not. That's a misnomer and a theory that's put out there that on the Mayans. They never actually had a doomsday prophecy.
Flat earthers, they literally used celestial navigation based on a globe.
Mayans didn't have a doomsday prophecy. That's a folklore surrounding the Mayan. But what I do want to deal with is how they were able to predict that alignment in 2017.
You have a citation they were able to predict that alignment? Because I've never seen.
You know what? The same scientists that gave you the globe actually had tons of documentaries saying we don't know how the Mayan was able to predict this. We don't know how they, all of that stuff. I'll give you the information on that too. You need to check that out. Yeah. You need to check. I'll give you the information on that, most definitely. So are you ready for my screen share at this time?
So you're saying the Mayans predicted the alignment of the planets in 2017?
Yes.
When their calendar ended in 2012?
The Mayan calendar just reset it in 2012. It didn't end. It reset. No, listen. The Mayan reset their calendar every 7,000 years. The Mayan calendars don't end just like ours don't end. We reset ours every year. They had different calendars, long counts and short counts, and they reset the long one is one of the counts. One of those long counts is a 7,000 year count where they will reset that calendar.
Okay, right. It didn't end. You're right. It didn't end, but it did. You know, it stopped. It reset, like you said, which would mean that any predictions they made were cyclical, right? It would happen again and again. You know, each time the calendar reset, it would, any predictions that calendar made would reset, which isn't the case.
I got
I'm genuinely looking, right? I'm genuinely looking, as in all the sites I would normally look at, and I see no reference at all to the Mayans predicting the 2017 alignment of the planets.
Not only the Mayan predicted it. Listen, let me show you. I'm gonna show you. I'm about to show it to you now. I'm about to show it to you right now. Then we finna get into. I'm about to get into it right now. I'm gonna show you I'm finna screen share and show you the proof. I'm about to show you the proof right now.
Right.
Not only did the Mayan predict it. This is what the ancient Hebrews predicted, and it was even interpreted in the King James Bible. So,
what, the alignment of the planets in 2017?
If you'll let me speak for a minute, please, sir. Like, wow, this is crazy. I'm about to go. Yeah. I got you. Yeah, I got you. I'm about to get into all of that because at this point, this is like beyond flat Earth. This is a whole ancient sort of debate. But let me just pull this up for you. The alignment that happened is right here. I don't know if you familiar with it, but here's the. I'm about. You don't. Yes, I'm not screen share. All right, hold on.
Oh no, you are. Why is it not? Sorry, it's not coming through. One sec. Come on. Give me one sec. There we go. Come on. Sorry, my computer's decided to just run slow for a second, which is always helpful. There we go. You're up. I do apologize about that.
All right. So.
Yeah, you're up.
All right. Thank you. When you look at Revelation here, just to show you how the ancient Hebrew had prophesied this, because they put it in their mythology. So I'm about to go here to Revelation with you. But when you look at Revelation here and you see the woman, the baby, and the serpent is trying to devour the baby. The woman is protecting the baby, and her feet is on the moon. That is all ancient symbolism that we plays out in the sky right here. We see Virgo with Leo. Leo is the baby, is Jesus and Virgin Mary going to war with Hydra, which is a great serpent. This alignment happens every 7,000 years, and this was put in Christian art as the reason the beast got 7 heads, because it was 7 planets, 7 luminaries that was involved in this great alignment. It was 7 luminaries involved in it. So her feet hold on, wait a minute. I just started. Don't make me pull this up to be interrupted. I'll let you speak. I'm just getting into it.
I do apologize. I'll have a smoke while you're talking.
Cool. Because I'm just showing you that ancient people were connected with the heavens. That's why the Bible said let the stars and all that be used for signs and stuff. So if you look at her feet on the moon during that September 11 alignment, if you pull it up, her feet was on the moon. Let's look at it. Let's zoom in on it. Virgo feet is on the moon. Leo is the baby, and they doing war with Hydra. And that's what we call the end of the world. It just represents the end of the calendar. The Mayan knew when they saw this in the sky, or the Babylon and the beast, how they saw this celestial sort of play happen, that it's time to reset the 7,000 year calendar. This alignment was 7,000 years. So that's what I'm showing you, the Hebrew, the Mayan, and I can show you several more people that talked about this same alignment. So the ancients were connected to the heavens, just to answer you.
Okay, so where does it say specifically from the Mayans that it was going to happen in 2017?
The Mayan talked about this same alignment right here. It did happen in 2017. But
where does the Mayans say this is going to happen in 2017?
The Mayan have the same mythology of the battle going on with Hydra in the heavens and all that at the end of the 7,000 year count.
I'm asking where can I look at the Mayan calendar and specifically find that this alignment is going to happen on the 23rd of September 2017? Or was that just an interpretation?
Well, check this out. You can't think about this. This represents the Mayan calendar being destroyed and rebuilt. So it'll be like saying, where can I look at the calendar of the year that you reset the calendar on? For example, the Mayan had a count of years that'll start back again at year 1 on the 7th after the 7,000 year. So after this 7,000 year period where this alignment took place in the heavens, the calendar would actually reset to year 1, day 1 again, and repeat this thing.
Okay.
So
okay,
yeah. So
that's not my question. My question is, how could I look at the Mayan calendar and determine that the alignment of all the planets would happen specifically on this date? Where could I go and find? Where could I go?
How you can prove that the Mayan reset their calendar at this 7,000 year period is after the long count, they stopped counting and they started back to year 1.
No,
that's the proof right there. The proof, listen, don't repeat yourself again. I'm trying to answer you and you're interrupting me repeating yourself. That's a tactic. Stop. It's rude. Let me finish answering you. Hold on. You're not letting me finish answering your question, sir. I'm in the middle of trying to answer you.
Go ahead. Go ahead.
Can you, thank you. What I'm telling you is this right here. The Mayan told this alignment in mythology just like the Christian did. You can't find a Christian calendar that's showing this end of the world. It's the end of a count. there's what you can find is what I just showed you, the symbolism attached to how this would happen in the heavens. The ancient Hebrews said this would be a fight that would play out in the sky because their ancient astrologers and astronomers didn't have modern scientific terminology. The church was ruling the earth. So their science was told in a form of mythology, which is why I'm screen sharing this right now. You're not going to find no calendar and all that in this time. It was medieval time where they was telling this astronomy and stuff as church, as it came out in their religion and mythology as a woman having a fight with a dragon in the sky. But they were really tracking time is what I'm saying. You're not going to find you're not going to find no calendar saying all of that. You're going to see the calendars reset and you're going to find the symbolism associated with the Great Reset.
Right, okay, but your claim is that the Mayan calendar predicted that this would happen on this specific date, right? So where can I find where it tells me it's going to happen on that specific date?
This is like your fifth time asking that question, but I'm going to answer it again another way. I got you. I'm going to answer it again in another way. The Mayans prophesied. Well, they didn't prophesy. They tracked the heavens and they were able to make predictions. So prediction and prophecy is totally different. What the ancient Hebrew called prophecy is simply prediction. The Mayan don't say on a calendar that this alignment going to take place on a calendar. They respect this alignment by resetting their calendar just like the Hebrew did. After at the end of Revelation, you can read this story that's taking place. Now, a lot of people saying that's biblical prophecy that we're waiting to look up in the sky and see a literal dragon fighting a literal woman. Some Christians are literally looking for these mythological creatures when it already happened. At the age of 7,000 years, what the Mayan were saying, life as we know it would dramatically change. And if you look at it, it is with the pandemic. So that's what they meant by world, not that the earth would be destroyed, our world, our way of living, our systems, digital banking, all of this stuff. But that's a whole nother conversation though, because now we are for flat earth and we're into.
Because my question was specifically, how did they make the prediction that this would happen on this date? You said, well, they honored the alignment by resetting their calendar. So did their calendar reset specifically on the 23rd of September, 2017?
The Mayan loan count reset at the end of every 7,000 years is what I specifically said. The Mayan got plenty calendars. Hold on a second. Let me show you. Listen, let me show you something. Let me show you something about the Mayan calendar. People think I'm trying to answer you right now. You can, sir, if you're not going to let me answer you, I'm going to leave, man. This is kind of getting annoying.
I am. I'm just trying to clarify things. That's all. So I'm just trying to clarify. I don't want to talk over you, and I'm not trying to do that. I promise.
The moment I start explaining, you cut. It's like walking and someone keep tripping you up. It's annoying, though. I want to speak fluently. Every time I talk, you cut in. Go ahead.
Right. So how specifically did the Mayans predict that this alignment would happen at that time that you've got on your screen there, once in 7,000 years, 23rd of September, 2017? So where can I find the prediction to say that the end of the 7,000 years is the 23rd of September, 2017? Because it was your claim that the Mayans predicted the alignment of the planets. So where can I actually find that prediction that relates to that specific day? Otherwise, it's not a prediction.
Right, cool. You can find, yeah, it's definitely a prediction because this happened the time that the Mayans said would happen. Now that's gonna be hold on. Wow, see what I mean? See what I mean, man? Like soon as I just started talking. I literally just started talking to answer you, man.
I just want to see where it says that. That's all, bro.
But the moment I start, I'm scared to answer. But here's the thing. I'm scared to answer you because I know the moment I start answering you, you're just gonna cut me off again, man. You don't see that's what you're doing?
Right, I will give you 2 minutes uninterrupted. I won't talk to answer the question.
Now why can't you just let me talk till I'm finished with respect, and cool, and we can pass the mic like I did for you. Because because the debate, excuse me. See, that's what I'm saying. Like, bro, you gotta do better with your guests, man. Like, we're literally talking over each other the whole show.
Okay, right. Please go ahead and let me know where this prediction was made. Please go ahead.
Now, I've been answering him the whole show. If my answer isn't satisfactory enough at this point, cool, we can agree to disagree. The point that I want to make to the people on my side, this is at this point not even a flat earth debate, and I think he's scared of the flat earth debate, which is why he want to debate the Bible. Hold on, wait a minute. Let me see. He can't even let me finish, guys. Can't even let me finish. If you disagree with what I'm saying, then when you get the mic, make your rebuttal, make your claim. I'm calling you out for as a content creator, this just gonna make our future debate more juicier. So don't get in your feelings, man. I wouldn't even come back if I didn't.
Apologize for interrupting you. Please go ahead and let us know where that prediction was made.
Okay. It's so cool, guys. The prediction, the Mayans said that in every 7,000 years, there will be a planetary alignment the way we see here. With Hydra is a sort of serpent-looking constellation, looking like a squiggly-looking worm or whatever, serpent-looking. We know what it looked like. The Mayan have a temple, Kukulkan. Let me pull it up. Where they have a seven-headed, seven-step serpent representing this whole alignment. There's like 7, Now this research right here, actually, your own scientists got documentaries on this right here, where they talk about the number 7 in relation to the serpents at Kukulkan. The serpent that the Mayan have there is Hydra. So they had a god to represent that serpent. And I'm about to show you that right now. This god here has the same symbolism associated with Hydra in the Hebrew connection with this count is what I'm saying. So the Mayan reset their calendars at their long count calendar at 7,000 years. Don't you find that ironic, though, that the Hebrews said their world is ending at 7,000 years, but their ending was associated with a new beginning, which is their way of saying a Hebrew resetting their calendars. So after this time, what happened on Earth was the government started saying we need a great reset. And that's what the Mayans said would happen. They didn't say that the sky would fall, everybody would die. That's all the superstitions and pseudoscience. Now, if you want to learn more about this, do your own research on the Mayan. I didn't want to spend too much time on the Mayan calendar debate because that ain't going to prove flat earth or globe earth who know the Mayan calendar. I would love to do a show about some other than flat earth, though, such as the Mayan calendar, where we can debate this kind of stuff, though. But I do want to go back to flat earth, though, before we close out, because I didn't mean to get too far off into the Bible, the calendars, the Hydra. This is we off track.
No worries. I hope you understand. I'm not trying to be rude. When I'm having a conversation, I like clarification. All right. I like to make sure that we're firm on the points we're talking about. So I hope you don't think I'm being rude. I'm not trying to talk over you. I'm just wanting clarifications on points. So based on what you just said, where can I see the date that they predicted this would happen?
The Mayans didn't have stuff. See, you're looking for like January, February, and the Mayan calendar don't got stuff like that. They didn't, like, if you think about, let's listen to what I'm saying. Your calendar today is based on a Pope Gregory calendar. When the Mayan made this calendar that I'm showing here, Pope Gregory wasn't even around yet. So to ask me to translate a Mayan count to a modern date it's something out. It's something that I'm gonna tell you right now. I have no problem saying that's something I'm gonna have to do for homework. I just couldn't do it here today. But what I will say is that the reason I referred to this date specifically in September 23, 2017, I think that's your argument. The reason I specifically referred to that date is because at that same time, this alignment took place over a long period. So during this whole time, it was like, it didn't just come and go. Of course, you know, it was a period of the alignment or whatever. So during that time would have been like this sort of reset to the Mayan is what I was saying. Now, I don't know if they would have, what exactly words associate to the time where they saw this alignment in their time 7,000 years ago. We call it September 23. They just called it a long count completed. You know what I'm saying? Because they said, according to even historians, the Mayan have saw this alignment over hundreds of thousands of years. So they had several long counts. So to them, it was just another long count. And I don't know exactly what date in our time synced to the last one in their time, but they did say we would have a situation where when we see this alignment in our time, it would be sort of a reset. And that's how the Mayans start being associated with doomsday, because that long count ends in 7,000 years, where a lot of the theologians say Revelation is said to carry out it. Like if you look at the ancient Hebrew right here, a lot of their theologians was telling this same alignment, but in their own way, distinct from the Mayan, but they all evidently was tracking this same 7,000 year alignment that only happens every 7,000 years. That was my point, to show that if the Hebrew knew about this alignment, then they must have been studying the stars thousands of years. And that's my proof that the ancients were very versed in the knowledge of the heavens. That wasn't necessarily a flat earth argument. It was just me big up in the ancient world. But that's another debate. So,
okay,
salutes,
so just to be clear, there is no prediction that this alignment would happen at this time.
Even modern astronomers and astrologers predicted this alignment before its time. So you might want to just look into it. Do your homework on it.
The Mayans, did they? So I just want to be clear. The Mayans didn't give us a prediction for this alignment at this time.
What I literally just, you know what? Let's move back to flat earth, man. Like I said, we spending much time about an alignment. As long as I understand there is no prediction. Look at that's absolutely cool. You know what? You win, man. I lose that when you win.
It's not about winning, man.
You know why? You know why? Because no sweat on my shoulders. That ain't even dealing with flat earth. That's just an ego argument, if you will. But let's get back to the maps and the flat earth, and off of the you know, we dealing with something else now, and I would love to debate you on that too. I don't know we can, you know what? This is my word to you. If you willing to have me back, despite the little tension, that's expected. That's expected among men. We're gonna turn up a little bit. Salutes to you in the chat. But if you willing to have me back, I would love to debate you on not just flat earth, any these other topics on what the Mayans said, predictions in the heavens. I don't know your religious status or whatever. Yeah,
we can talk about all of that, right? 100%. I produce for another channel called Skatoon Show, which is an unbiased debate channel. Would you be willing to come onto there and have like a moderated debate?
Oh yeah, that's fine. Just email me. We can set it up.
Yeah. That's 100%. But yeah, I'd like to continue talking about flat earth, because
for sure.
One thing you said is that, you know, there's no evidence that the earth is rotating, right?
Yeah, I definitely believe that I'm on a stationary plane. Correct. Go ahead.
Okay, so how do you explain the fact that we can literally measure the rotation of the earth?
I don't explain it. I let you do it. You're the globalist. Go ahead, man. Go ahead.
so you're aware, we can measure the rotation of the Earth, and it's actually relatively easy. I mean, so easy that a flat earther has done it. I'm sure you know about Bob Nadell, right?
No, I know him, but I ain't into, like, I want to deal with my own. I don't really want to, because it's kind of going to look a certain way where it's going to be kind of messy if we bring him up. Me and him ain't really, it's a long story. Let's just.
He doesn't like me either. Don't worry. I messaged him, "Hey Bob," on Facebook, and he blocked me instantly. So yeah. But Bob, bless his cotton socks, did a good job for us by measuring the rotation of the Earth. So, and this is just one observation of a measurement of the rotation of the Earth. There's many, many, many more. But just this one is one that I like to bring out because it was done by a flat earther.
And was it on the behind the curve, or was it on a documentary?
Turn 50.
But I've also got other videos of it.
Listen, Bob proved the globe in that video, if you ask me. I'm just being funny.
That is kind of point.
Yeah,
so,
but
just watch this video just for a second.
I know about the video, man. I'm a flat earther, bro. I've watched it, but yeah,
I know this is kind of for our audience. Just a sec.
In today's 21st century,
but you can't. I don't really want to be associated with Bob because of stuff like this, though. You know what I'm saying? Like,
this is part of my evidence of the Earth rotating. So just
well, that's your evidence against Bob, not me.
No, it's the evidence against the Earth being stationary.
Actually purchased one for $20,000.
Yeah, Bob ain't the spokesperson for this though. Like
on that gyroscope,
I would debate him on the same video.
The fact that Bob is irrelevant, it's what he
15
did.
degree per hour drift.
I don't even agree with his experiment. I'm with you on this. I'm saying it's a horrible experiment and it's stupid. If anything, he failed. Because I think he failed at doing what he said he set out to do, plain and simple. Next topic. I don't want to talk about Bob.
No,
Hold on, why you want? Wait a minute. Can you respect my wishes not to discuss that man out of respect? Because I don't want no beef with him. I swear, man.
Okay, I mean, the fact that it's Bob is irrelevant. It's what he did is the point.
Didn't do it, though. I didn't do it. Can I talk about my research, my experience? You debate me, not Bob. Forget him and what he doing. What about me?
Okay,
I'm Sanchez.
Evidence that the Earth rotates, all right?
Man, I don't agree with none of that, though. I don't care about that video.
Okay, then that's why, after I show the evidence, you can try and give a rebuttal as to why it doesn't show that the Earth rotates. Is that fair? Right, okay, let me do something else, right? I will show you another experiment that demonstrates that the Earth rotates and explain it, okay?
Thank you. That's better than going to Bob Nodal. Thank you. That's better.
Right. And then I'm going to, after the explanation, all right, I'm going to ask you a question, and then we can go from there. So
and salutes to Globe Busters, by the way. I'm not throwing salt on you. I'm just saying I want to make my own arguments and be my own man today, and I don't want to be associated with anybody for business reasons and personal reasons. Go ahead.
Okay, so here we go. This is a guy called the Gentleman Physicist, all right? And he did something very simple, and that was measure the rotation of the Earth with a swinging pendulum, okay? So if the Earth is rotating, yes, I'm going to beg the question because that's what you kind of do in science for experiments. If the Earth is rotating, then as a pendulum swings back and forward, it will swing relative to the Earth rotating independently to it, okay? Which means that at different points on the Earth, there will be different amounts of forces induced onto a swinging pendulum. And that gives us an ability to make a prediction, right? If the Earth is rotating at 15.04 degrees per hour with the circumference that we say it has, that means that the amount of Coriolis force induced onto a swinging pendulum will make a drift that corresponds to your latitude on Earth, which means that the rotation of the Earth can be measured simply by the drift of how much the pendulum goes off of its straight line path. So what he did was he made his own pendulum experiment in a local high-rise building. The string of the pendulum is a monofilament fishing wire and it's a big bit of concrete and plastic that is swinging backwards and forwards, right? So he lets it swing, and it swings backwards and forwards over this little ink pad, okay? As I explained at the beginning of this, if the Earth is rotating, that means that the Earth will rotate independently of that swinging backwards.
Can you rewind it to the beginning again, to when he first started the motion of it, please? Yeah, there you go. All right, yeah. All right.
So as the pendulum swings backwards and forwards, right, it would naturally have a straight line path. If the Earth is rotating, it imparts the forces that make a drift, okay? So this is the method that they say is the best to make sure there's no kind of bias put onto it left or right. You just burn the string and inertia takes over.
Oh, well, hold on. Let me ask you something. Pause it for a second. I got a question.
Let
I
me
know,
finish.
just pause it. I got a quick question. It's fine. I got you. I'm watching it. Just pause it. I'm thrown off, though. You're going to leave me confused? I'm confused about something. You're going to move on, and I'm confused.
Well, I hope that the rest of the explanation can assure that confusion.
It'll be very quick. What I'm saying, if the Earth, if the Earth is in motion, wouldn't he just leave the ball still and let the Earth's motion independently set it in motion? Why would he burn a string or touch it or anything?
Because the point is the pendulum has to be swinging for the experiment to happen, and the ball.
Yeah, but when we let the Earth, the natural rotation of the Earth should start it, right?
It shouldn't, because the pendulum is rotating at the same speed as the Earth, even though it's going backwards and forwards. It's on a pivot point. So no, we don't expect.
You can play the video.
That isn't the point of what happens, all right? So, as you can see, when it starts, it's going backwards and forwards, and it's a straight line path, okay? However, after, I think, 41 minutes, you can see it's no longer a straight line path. Well, it's still a straight line path, but that straight line path has drifted compared to what it was before, all right? Now, this is in the Northern Hemisphere, which matches the first prediction. If it is in the Northern Hemisphere, that drift should happen clockwise, all right? The next prediction can be made by, first of all, finding out the period of rotation, how long it will take to do 24 hours, right? Which is T, which is pretty simple math. You times how long it took by 24 hours and get what you need for that. And then what you do is you measure the angle, right? So they measured the angle, the amount of drift, and they got 7.89 degrees over that 41 minutes, all right? Which is 0.688 hours. And that allows us to do a calculation and make a prediction, all right? We know the period of rotation here would be 31.4 hours. So we can use the fact that we know how much it has drifted over that time to calculate our latitude on the Earth. The latitude on Earth would equal arc sine times 24 hours divided by T, the period of rotation, right? If the Earth is rotating, it explains why you can make this prediction. And what happens when they do the math? Well, they find out that the latitude 49.8, which is about 1.4 degrees off, which is about 0.4%. So over 99% accuracy, all right? So 1.4 degrees. So here's the thing, all right? That drift corresponds to his latitude on Earth because the Earth is rotating and imparting the Coriolis forces which make that acceleration happen, okay? That is explained by the fact the Earth is rotating, allows you to not only predict which way it's going to go, but your specific latitude on Earth, and it happens in a different way depending on the northern and the southern hemisphere. So my question to you, Bro Sanchez, is why does this happen if the Earth is flat and stationary? What is the physical mechanism behind a drift corresponding with your latitude on Earth?
Yeah, I've already spoke on the whole pendulum situation several times on my channels. I think that it's all have to do with the whole start of the experiment itself. I just don't agree with this kind of, I say with these kind of experiments, you have to do it on your own to make it legit. Hold on, listen, I'm trying to answer you.
I was just agreeing with you.
Wait a minute. Okay, cool. Yeah, we got to do all these experiments on our own, matter of fact. But the thing is, I really think that if the Earth is in motion, we really should suspend the ball and let the motion of the earth naturally set it in motion. Now I get what he doing in this video, but the pendulums that they got in these buildings and all of this stuff, they set them in motion the same way. They never let the natural movement of the earth start the motion. I think that the experiment itself is kind of flawed. I'm not going to really speak on this pendulum experiment with dealing with the spin of the earth, because what led me into flat earth and what led me to say where the earth ain't spinning had nothing to do with this experiment. And I have to be honest and say that. So I will let you actually deal with what I actually dealt with to make me say, no, the earth can't be spinning. The question.
Okay,
first I have a question. First I have a
about that.
Let
me just respond to that quickly. You said that the pendulum should move on its own, and that is just wrong, okay? Because there's nothing about the way that the earth rotates with a pendulum on it that says it should start swinging on its own. Because if the pendulum is just sitting there, that pendulum, the pivot point is attached to the string, everything is rotating the same speed as the earth. The point of the experiment is that once the pendulum is swinging, then you can use the corresponding drift to figure out your latitude on Earth, right? And that is a direct prediction that the globe makes. So it doesn't matter if this isn't something that took you to flat Earth. This should be something that should make you think, well, there's no explanation for this on the flat Earth, none at all. There is no plausible mechanism as to why this happens if the Earth is flat.
But I didn't make one of them because different flat earthers use different observations and research to debunk the spin.
You've gone a bit quiet.
Oh, my bad. I said I have seen several videos, several flat earthers approach this whole pendulum topic. I haven't approached it yet with my own video. I've spoken on it in debates like this one briefly, but the reason I don't is different flat earthers show their own arguments for why the earth ain't spinning. I show a whole nother different set of arguments for why I believe the earth is not spinning. Now, here's how debate work in my opinion. I think if this video is proving that the earth is spinning, then you've done a good job presenting your argument. And I think when it's my turn to get the mic, then I should be able to show my own independent experiment and research of why I think it's not spinning. I don't think I have to actually perform this experiment at the moment and deal with it. That's why I said I'm not going to speak on any observations or experiments I hadn't personally done in a debate. You're presenting his research and your argument, which is a good source, but I have my own independent sources of my claim that the earth does not spin that I would like you to check out.
The fact is that this experiment is done worldwide, though. I've done it myself at a university. You know, it's done all the time. I'm not debating you that it wasn't done worldwide or nothing like that. Here's what I'm saying. I don't think you're hearing me. What I'm saying is this right here. Okay. What led me to say that the earth is not spinning had nothing to do with this experiment, right? I would like to present some of the stuff that led me to say the earth is not spinning to you right now. You presented something to say it is. Why do you got to control the narrative? You can't. I'm not trying to control the narrative. I just wanted to hear if you had a rebuttal for why it happens on a flat earth, because the fact is this does happen, right? It's not something that can be denied. This is an effect that happens in nature.
That's your question. If that's your argument, it should be able to stand, and the people in the crowd will say, "Well, hey, he got you on that one, Sanchez." But can we move forward though with my stuff now? That's all I'm saying. You kind of. If you don't have
I'd love to hear your evidence for the Earth being stationary.
Right, because if we're talking about a stationary Earth, I have a whole nother approach. I can't let you control my game plan, if you will. So check this out. I have a question. Just got a question for you real quick. Is the ground that I'm walking on moving at a different speed than the atmosphere above me?
in general, the atmosphere and the Earth rotate at the same speed. There is a slight difference because of, again, Coriolis, the further you go up. But in general, the atmosphere rotates the same speed as the Earth, yes.
And so when we lift up off to the ground and we suspend it in the air, we're still sort of moving in that wave. So again, in a small scenario where one can say, if that's true, why can't a helicopter hover off the ground and the Earth just keeps spinning and you drop down and it'd be a different location beneath you? Small observations like that. So my thing is, would an airplane move with the atmosphere and at the same speed of the atmosphere? For example, if you're saying the atmosphere is moving at 1,000 miles per hour, when a plane that's traveling in the opposite direction go against the grain, like that's a lot to move against. Or if you're going with the atmosphere, you can never make it to the city that's moving in unison with you. You know what I'm saying? Unless you add 1,000 miles per hour to your speed.
I think you're really misunderstanding how it works here, because the atmosphere is rotating.
Help me understand.
Right, the atmosphere is rotating with the Earth at every point. Okay, which means that relative to the Earth,
synchronicity, right?
Yeah. I mean, almost, right?
Almost.
Which means that relative to the Earth, the atmosphere is stationary. We're going to ignore wind here because wind is a separate issue, but because the atmosphere is moving relative to the Earth.
Atmosphere is wind, right? Gases.
No. Wind is specific.
Hold up. When we talk about how fast the atmosphere moving, I thought we were measuring wind speed.
No.
That's what like atmospheric gases in motion.
Right. Let's make the assumption that there is no independent movement within the atmosphere, and the atmosphere is moving completely in lockstep with the Earth,
ground.
Right? Which would mean that in this case there is no wind, because the atmosphere is it's relative to the Earth. Which means that
there is no wind in this case. Okay, go ahead.
It's just for a thought experiment, right?
Wow.
I'm not saying that's reality.
Okay, no, man, you got it, bro.
We're just trying to say that the atmosphere is rotating with the Earth, which means that relative to the Earth, the atmosphere is stationary. Which means that if an airplane is flying either way, it's using that reference of the atmosphere being stationary to the Earth to fly in. So you have to think about the difference between airspeed and ground speed. An airplane compares its speed to the ground and to how fast it's moving through.
But I thought you said the atmosphere and the ground is synced together and moving in the same speed.
Yes, and the airplane is moving through it.
Right. So why would we make a difference between air and ground speed when they're synced and locked together? That's dumb.
Because you have to compare one to the other. You can
say,
well, I'm moving this
in comparison, according to you, see, I got you right now. According to you, you said that the air and the ground is synced, moving together like this. Once what we observe is that there is no distinction between the speed, so why would you make one now? When the airplane gets in the atmosphere is moving at 1,000 miles per hour like the ground is beneath it. So if the atmosphere is moving... So if the plane is traveling at 700 miles per hour, the same direction of 1,000 miles per hour atmosphere, it would have to add 1,000 miles per hour because it'll never be able to move as fast as the atmosphere that it's traveling through. You please tell me how this would make sense.
Okay. So true airspeed is simply the speed at which an aircraft is moving relative to the air it is flying in. As such, it's also the speed at which the air is flowing around the aircraft's wings. Ground speed, on the other hand, is simply the aircraft speed relative to the ground.
Are you Googling that right now?
I was getting these specific definitions for you so that I didn't, I made sure it was right.
On a globe Earth, it's the air and the ground sync together.
Yes, but the air is also a fluid. Okay? So as an airplane moves... As an airplane moves through this fluid... Okay, that's going to change the airspeed relative to the wings because the atmosphere of the air is a fluid. And because of that, there is relative speeds for the air going around the wings, which is going to be different to the relative speed to the ground. Even if the atmosphere is moving in lockstep, it's a still day. But because the air is a fluid, moving through the air is going to give a different airspeed.
Okay.
Does that make sense?
So when the pilots are negotiating flight, they're talking about atmospheric conditions. That includes wind speeds, because all gases are a form of wind. Helium.
That's a form of wind. What does that mean?
All I'm saying is wind is a state of matter. Gases travel in what we call wind, whether it be helium, you name the gas. That's why we say airborne diseases.
Sorry, I'm not understanding what you're saying there. All gases travel in wind. What does that mean?
What I'm saying is this. If the atmosphere on a globe Earth is synced to the ground, the atmosphere is composed of air. That air is just a general word for all the different gases in motion that's up there. You're telling me that these gases in motion that we call the atmosphere above the ground is moving at the same speed as the ground in synchronicity. That's what you were saying earlier. I'm trying to establish that so I can make a point. Don't take too long. I'm trying to establish, is that what you mean, so I can move forward? Because you said yes earlier.
So, I mean, I was very confused by what you said there. I said that the air is a fluid. That's how I described it.
That ain't what I'm asking you. What I was asking was,
I'm dealing with a different thing.
I'm not dealing with, no, hold on. You're not hearing my question. Wait a minute. Let me ask it again. I'm not dealing with the makeup of these elements. I'm dealing at the speed of them. The atmosphere is composed of gases. I want to know what's the speed of these gases compared to the ground I'm walking on, because that would be relevant to a pilot that's flying through this atmosphere.
And yeah, okay, so if it's a still day and there's relatively no wind, then the speed of the gases would be relatively zero compared to the ground.
So the atmosphere on a still day is not in motion?
Relative to the ground. The ground is moving, the atmosphere is moving at the same speed, which means that relative speed between the atmosphere and the ground is zero.
Okay, if the atmosphere is moving at a speed and the ground is moving at the same speed, that is what they say is 1,000 miles per hour, roughly. I have a question with that.
That's not right. You know the 1,000 miles an hour is tangential at the equator only, right?
That's cool. You want to give me another number? We can use it. I can use another number to make my point.
Earth is rotating 0.0000694 RPM. The 1,000 miles per hour is a tangential velocity only.
Okay.
At the equator.
Okay. So does that count for the ground at the equator too? That the ground at that part of the Earth is moving at its own independent speed than the tips too?
The entire Earth is moving at 15.04 degrees per hour, or 0.000694 RPM. That's how fast the entire Earth is rotating. At the equator only, that means that the surface of the Earth has a tangential velocity of 1,048 miles an hour. At every point around the surface of the Earth, the air will have the same tangential velocity as the ground beneath it.
Gotcha. Now, so my thing is, though, if I look at the speed of the Earth's atmosphere according to what they said as like a whitewater river, right? Some rivers flow at slow speeds. Some rivers flow at high speeds. Now, one would say if you're going to sail in there, going with the grain would be the best way. Going against it, you know how that go. I look at the atmosphere the same way. If you're suspended in a medium, right? And the medium is in motion like a river, you do have to account for the speed of it. And if you're telling me that it's so many, so if I'm in a river, I don't have to account for the speed by, Huh?
The river wouldn't be moving the same relative speed as the ground around it. The thing that you have to understand here is that the relative speed between the ground and the air is 0. The difference between
Wait a
them
minute.
is.
Okay? I got you on all that. I got you.
If the plane is in that, which is going with that relative 0, there's no river or rapids that
listen.
Going.
Here's what I'm saying right here. Once you're suspended in the air, the speed of the ground beneath you is irrelevant, which is why I keep talking about the speed of the atmosphere. I ain't even talking about the ground no more. If the atmosphere is a medium, you just said you compared it to liquid a minute ago. So now I'm agreeing with you. Wait a minute. Right, cool. Like a river. Like I just compared it to a flowing river. So I'm on the same page. So the atmosphere above us is not in motion.
Relative to the ground, no. Did you understand what I mean by that? Relative to the ground, there is no motion. A river, relative to the ground, would have motion.
Listen, you're saying relevance to the ground because they're both supposed to be synced in at the same speed. I get what you're saying. Yes. I get what I'm telling you, it still doesn't change the fact that I got to account for said speed when I'm on either one of them. Like there's a reason we design. Hold on, you got to let me finish. I got to finish here, please. You got to do at least one time. Let me finish. What I'm saying is, you act like I don't understand what you're saying, and I totally understand it. I just don't understand how a pilot can ignore these crazy speeds is what I don't, which is why I'm finna ask my next question. The atmosphere is a medium. You're still moving through a medium that you said goes at said speed. I don't care about its relevance to the ground because its relevance to the ground don't change the fact that I still would have to account for that speed once I travel through that medium. So that's why so wait a minute, I'm not done.
I was just agreeing with you.
Yes, so this is why we design things that we said we want things to go faster, right? Because we're moving through a medium. If I was moving through dirt, I would have to have a drill head and design myself different than an airplane. We design technology based on a medium it moves through. The speed of the medium that things move through is very important, and that's being ignored in the question that I'm trying to get to right now. So let me ask the question. The speed that the atmosphere is moving, when it comes, and I'm going to look it up what they teaching right now because it have changed how fast currently what they're agreeing with in science. So we can have a universal number just instead of me and you, it say right now, like you said, at the equator, it's about 1,000 miles per hour, like I said. So I'm making my debates from a scenario imagining if we were on the equator, if we were at that part, if we were in Ecuador right now on vacation, right? Let's just think about it. So that's what I'm saying now. The atmosphere at that point is synced with the ground, like you said. Let's use that 1,000 miles per hour because you said a lot of stuff, and I was agreeing. I was trying to get to the question, which is, since I have to account for that 1,000 miles per hour in the air, once I get up there, remember, it's telling me it's in motion 1,000 miles per hour. So depending on which way the earth is rotating and which way I'm going against that said speed will dictate how much force and thrust I would need in my jet or 747, because these speeds would affect your flight as a pilot. And that's all I wanted you to deal with was how do a pilot accounts for this 1,000 miles per hour once they suspend it in a medium that's going that fast. Like if you push me in a river that was moving 1,000 miles per hour, for example. So that's all I'm saying right there, man. Yeah,
so
please.
the plane is moving with a relative speed to the atmosphere. It's as simple as that. The atmosphere is the fluid that the plane is using to create its lift and its thrust. So the plane is moving with a speed relative to the atmosphere, which means that there is no 1,000 miles an hour to take into account, because that's the same speed that the plane has when it's on the ground before it takes off. It doesn't all of a sudden lose that 1,000 miles an hour tangential speed when it takes off. It still maintains that. It still has a relative speed. Let me finish, please. Let me finish. It has a relative speed compared to not only the ground, but the atmosphere, which are also connected. A plane has to fly through the atmosphere, not against a movement, because they're relative to the plane. There is no extra movement. That, if the plane could hover, it can obviously, but if the plane could hover, it would again move with the rotation of the Earth. So if the plane then wanted to go forward at 500 miles an hour, regardless of how fast the Earth is rotating, it only has to travel 500 miles an hour relative to that atmosphere, which it and the ground, I haven't finished, it and the ground would appear stationary. It's all about, the fact that they are all traveling at the same speed. They are all connected. Conservation of momentum means that the plane wouldn't all of a sudden lose at 1,000 miles an hour when it goes into the atmosphere. That would require a force in the opposite direction. Does that make sense?
So got you. So check this out. So the next question would be, because you said so much and you made me miss my question. It was just a quick interjection of what you said on the previous line there. You was going real fast. But the thing is, if the plane is moving at 1,000 miles per hour on the ground, the moment it suspends from the ground, it's still moving, like you said, 1,000 miles per hour with the atmosphere. Technically, we could say that when the plane is doing 500 miles per hour, when the atmosphere is really doing 1,500 miles per hour, the plane...
You can.
Hold on, wait. Yeah, you can. I got you. That's what I'm saying. Now, check how deep this is. If the plane is battling this 1,000 miles per hour all the time at this equator, being that it's synced with this 1,000 miles per hour. Now the Earth, let's say, because the Earth is spinning, is spinning at different rotations above and below the equator. Let's just say you're part of the equator where the Earth is spinning clockwise, right? 1,000 miles per hour. But you want to travel counterclockwise like we see a lot of planes do. What would it look like now? Because I get what you're saying. If the ground and the Earth is moving this way together, but what if the airplane want to move that way against the current? Now the Earth, wait. Hold on, you got to let me finish explaining, and I'm gonna ask you.
Sorry, I thought you'd ask the question. I'm
gonna let you know when I'm through. So I got you. According to what you said, the ground and the sky is synced at 1,000 miles per hour. I want to slow down with this so you can hear the question. Please don't interrupt me. I'm gonna let you know when I'm done.
Go ahead. Yeah.
All right. So when the airplane gets suspended, your example sounds great if the plane is flowing with the direction that the Earth is going with the ground. I get the concept of them being locked in, but if the plane is going in the same direction of the 1,000 miles per hour, that'll kind of explain, like you said. Now he's going 1,500 miles per hour because you got to add the 1,000 that he going with the atmosphere. But if he going against it, you got to subtract the 1,000. Now we're going to be in the negatives now. And for him to get amount of thrust to go against it, it ain't going to be the same as going with it. Very simple stuff. Explain why. Explain it in reverse. All I'm asking you to do in my question is to explain it in reverse now.
Okay, so again, all speeds are relative. The atmosphere, the fluid of the atmosphere, has the same relative speed as the ground, and that is what the plane is using for thrust. As I said, imagine that the plane was just hovering. That's not the case. It can't do that, but just imagine that the plane is hovering, and it would be rotating at the same speed as the Earth.
Right.
So now, if it wants to go against the rotation of the Earth, all it has to do is move relative to the atmosphere and the ground. The same way that a car doesn't have to go twice.
That's the part I don't get, because that's crazy.
A car doesn't have to go twice as fast to go against the rotation of the Earth, because like the plane is using the fluid of the atmosphere, the car is using the physical matter of the ground to create its thrust to move. Wow. So they're exactly the same. No matter how fast the Earth is rotating, the plane always travels relative to the Earth as though the Earth were stationary below it.
I just don't get.
That's not evidence of the Earth being flat.
This is what I don't. This definitely debunks the globe, man. You're doing a horrible job with this one. Let me ask you this right here. This is why I cut my camera on with this one. My chat is on fire, and we doing big numbers over here. By the way, let me share some with you real quick. Here's where it gets me at. You like to use the word relative as the end-all, be-all magic key out of this, but it's just not going to work with me. We just explained that according to the Coriolis effect on a globe, the top spins different than the bottom. We're literally talking about the speed by which each one spin. They say 1,000 miles per hour. You accounted for the speed, and we agreed that the plane moving in synchronicity with the current, he will move at 1,500 miles per hour. It can't move at 1,500 miles per hour against the current and still have the same results. This is stupidity, and I'm about to explain to you why it's stupidity. The moment you said, hold on, you gotta let me explain it now. I let you talk. Here go my argument.
I just need to get that in my head. There is no current. I'm just remembering that.
Let me. You can call it whatever you want to call it. I'm using current because I brought up the river earlier, so my mind kind of tracking on that. We're not gonna have a semantic debate. I'm using the word atmosphere, and I refer to the Coriolis effect, and I got my screen share up on my end showing everybody exactly what I'm referring to, what's on the screen about the Earth's atmosphere at the equator. We both know what I'm talking about. So why would you play a semantic game? Let me finish my conversation. Yeah, we know we talking about the atmosphere, and I was just using the way that it moves in relation to a medium that's in motion. And a river is a medium that's in motion, which was a good synonym and a good analogy. You don't have to accept the analogy. I just need you to understand where I'm going now so we can move on. You distracted me. I'm trying to move forward. Here's where I'm trying to move. The speed of the atmosphere, you took it into account because you said the airplane would be moving at 1,500 miles per hour, but that would only be true if it's going the same direction that the atmosphere is spinning at speed at. Because if just say there's a merry-go-round spinning in front of me, and the merry-go-round is spinning at 1,000 miles per hour counterclockwise, if I can match that speed, I won't get thrown off. It's like jumping on a treadmill. And I can also go faster than that speed, but trying to go against it will be kind of different. That's work totally opposite. My thing is this right here. You added 1,000 to show that the airplane is gaining an extra 1,000, but that would only be true if it's moving in the same direction of the atmosphere. If it's moving against it, it will have to subtract the 1,000, which is why I use upstream and downstream to make this example. It can't be the same both ways. It's scientifically and mathematically impossible. And guess what? At this point, I'm going to let this be my last argument because I think this the nail in the coffin for me and my food getting ready too. But I definitely want to do a part 2. You lucky. But yeah, go ahead, my brother. Yeah, go ahead.
So the main issue is you're not understanding one simple fact, and that is that speed is relative. Let me just say, right, okay, the analogy between a river and the atmosphere is false because the river does not have a relative speed of 0 compared to the ground, whereas the atmosphere does. The big issue for you is that if what you're saying is true, when I was in a train or that's going 200 miles an hour to the east, and I wanted to walk to the west, I would have to struggle to walk to the back of that train. But that doesn't happen because speed is relative. The plane is traveling with a speed that is relative to the ground.
It does happen.
If the plane was hovering it would have a relative speed of 0. Now, that doesn't matter how fast the Earth is rotating relative to the rest of the universe, because the plane is rotating the same speed as the Earth and
you know
atmosphere,
what?
and the atmosphere,
I'm
which
glad
means that there's a relative speed of 0, which means that whichever way they're going, the ground speed is going to be the same.
Look,
right? The 1500 that you're imagining is only a relative thing compared to the outside universe. That doesn't work. We're comparing it to what's happening on Earth, which is the same as saying if a train is traveling 200 miles an hour to the east, and I want to walk to the back, which is heading to the east, it would be harder for me because I'd have to go 1500 miles, an extra 400 miles an hour. But that isn't how it works. Speed is 100%
relative. Okay, cool. So tell that to the man in the Ferrari on the highway. But check this out, right? Let me just say this, right? This is crazy because you gave an example of being on a train and being able to walk either way and not feeling nothing. My answer to that would be you obviously ain't been on a train. I just ride the city bus. Hold on. Wait. I'm finna make my argument. I know you have. I'm just joking. Let me make my argument. You interrupt me on purpose. We know those are tactics. But let me finish though. Anybody that ever rode inside of a bus, a train, a car, anything, like when I used to ride the city bus, when you walk in the same direction that the bus is driving, you actually pick up a little momentum and speed with you. When you turn around and walk back, it's almost like going uphill. It's the same way when you're in a car and someone jerks on the gas, you get pushed back. But if you going in the same direction, just say when a car is moving forward, if you're moving in the same direction with the car or against it, you will be able to detect that he made an example like you wouldn't feel it. But this hold on, wait, I'm not done. This same argument would work on a globe that's in motion. Once I'm inside of something that's in motion or on something in motion, this same law would apply. That I would gain momentum moving with the speed of the thing and lose it going against the grain. That's all I'm saying. To deny that what I'm saying is to deny the fact that when we're
I'm sorry, I am going to deny what you're saying, because if a train or a bus is traveling at a constant velocity, no bumps or anything, there is no difference
with your interjection, man.
Way. There is. Sorry, I thought you'd finished. It seemed like you'd finished, but you're wrong. There is no difference as to how hard it is to go either way. If a train is traveling at a constant velocity, the same as if a bus is traveling at a constant velocity, it is categorically not harder to walk one way than the other. That simply is not a thing.
So let me ask you something. If there's a treadmill in front of me, right? Let me say something, guys. If there's a treadmill in front of me and the treadmill is moving at 1,000 miles per hour, what happens if I hop on that treadmill and don't match the speed? You see people get spit off like that, right? So it's the same doggone situation here, to where when you hop on a moving treadmill, you got to match the speed of it, or if you go against the way that the treadmill is spinning, then it's like an uphill climbing that motion. You're saying that this wouldn't matter on a treadmill, it wouldn't matter in a car, it wouldn't matter on a plane, it don't matter on a globe. You can just go either way and it's totally fine. At that point, I'm gonna say you win the debate here today. I lost, I gotta go, but you win. If that's your argument, you win. If that's your argument, you win, man.
Just to say that going
really
the ground treadmill moving 1,000 miles an hour is different to having a relative speed of 0. But
yeah,
you need to
you
go
like the word relative.
Yeah, because that's a very important thing when you're talking about speed. Very important.
Right.
There's no such thing as absolute speed. It's all relative.
Right.
But if you need to go, Bro Sanchez,
all relative.
I want to say thank you for taking the time to come on. It's obviously that it's agitating. It's we're both excited. There's going to be a bit of talking.
Oh, it's fun. I think in general, it's fun.
We did okay, and I would love to have you back on to the Skatoon show, and maybe speak to one of the members of the channel, Michael Toon, because he is also very good at explaining a lot of parts of evidence. But I'll email you about that, and anything that you have questions about from this debate, please email me and let me know, and I can get you that information, okay?
Hey, I think it was a fun show. I like the energy we had. It was what the people want.
Man.
And that's what's up. I look forward to the next one. It was fun, and that's the main thing about it. Salutes to both sides, flat and globe. Just remember, keep questioning everything, and that's just about it. Just keep questioning everything. That's it. Peace and love to everybody. I'm out.
All right, take that. We'll speak soon. Enjoy your food.
All right, thank you. Guys, I'm going to probably come back maybe later. I'm gonna grub a little bit and then meet y'all later. I ain't ate nothing since like 7 this morning. I ain't really eating nothing in. It was a smoothie, so it's 5 something now. And yeah, man, I shouldn't have even done that on an empty stomach. But it's light work though. Like, I knew what it was gonna be with him. A bunch of gravity, relative, relative. Speed is just relative. You got any relatives? You got a mama, daddy, cousin, auntie, relatives. Just relative, just relative. It's no real observations using your head, you know. It's just program response. Gravity, relative, gravity, relative gravity, relative gravity, relative gravity, gravity and relative, relative, gravity, relative. God damn, bro.
Stupid.
And I knew what it was gonna be. He act like he's saying something different than all the other ones, other than gravity, relevant.
Stupid.
Hey, yo, man, look. But the amount of times that he interrupt, I know he doing it on purpose. I know for a fact, I know debate tactics. That's the only thing about him, right? You interrupt too much and you don't have to, bro. And you know it's throwing a nigga off. And that's that slick shit I don't like. If you got to win a debate that much like that, bro, come on, man. That's cheating like a motherfucker. Shut up when somebody talking. Like, soon as a nigga start talking, damn, that shit was annoying. You know what I'm gonna do? I'm going to read the cashaps now. I knew it was something I had to do. I'm tripping, yo. Yo, big salutes to Isabella Washington. She the only one hit the cash app today. Let's drop a bomb. I mean, this dude told me on the thing, on the email, you know, it ain't really a debate. We just putting that in the title because the people show up when you put that there. But I'm more just, you know, kind of getting to know you and letting you kind of introduce yourself leading up to the debate or whatever. So I'm on the impression that I've done several of these. All I got to do is show up kind of like on the Killer pre-show with my slides and my questions or whatever. And cool. But it turned out to him doing more talking than I thought he was going to do. You know what I'm saying? I had so many folders and questions that I didn't get to go to because of it. And we ended up talking about the Mayan calendar. Like, a lot of that stuff was like, you're trying to kill up time to keep me off your ass with these basic arguments about this flat earth. And when I catch your ass cornered, you say, oh man, well, that don't really matter. Who cares about the zodiac wheel? I do, because I just killed your ass with it. The people at the bottom of the globe should have their own wheel. The fool, he contradicted himself. I led him up to that damn nail in the coffin. I said, so the people on the bottom of the earth, they see a different set of constellations. He said, yeah. I said, so where they different zodiac wheel at? Well, it don't matter. The Babylonians went round the earth and all this old bullshit. Y'all let that boy fool you. He won't just because he like to sound smart. He can't explain to me why them people at the bottom of the globe who he said got a different set of constellations ain't make their own wheel form. Set up there talking about where the Babylon, relevant. Just crazy stuff. Them people would have made their own map of their sky. I'm pretty sure they had birthdays and star signs. They didn't wait to have star signs till the Babylonians gave it to them. This is ridiculous. How did everybody on the world have birthstones that sync to one zodiac wheel, but the people in the southern part of the earth got the same birthstones and wheel? But you said they got a whole nother different reality when they look up in the sky. Y'all can let them fool y'all if you want to. That's easy money for me right there. And I ain't got to even raise my voice no more. Salutes to the people. Sean Mormon, thank you for that flat motherfucking power. Hey, salute the Nat Cone Code. Thank y'all for these donations. Profile 76. Much love. Yeah, man, I'm just sticking around for a minute in case y'all want to hit the cash app button, man, or whatever. It's I know a lot of people still donating, but we definitely gonna come back and probably do a post-debate show and chop it up, open up the panel, and do all that good stuff. But yeah, man, like I got him on so many arguments. And I think I need to turn up a little more in these debates because it make my arguments have a bit more impact. I don't really like the sarcastic, laid-back Sanchez. I think I'm going to have to go kind of give him a little of that fire like back in the day, just a little bit. Because on certain like I turned up a little bit with him today because, bro, some people say I was interrupting him, but if you go and look at the show, y'all ain't see his tactics. He'll bring up straight up side arguments that have nothing to do with the narrative of the point that he sees I'm trying to make just to throw me off. And if I don't hurry up and grab the mic back and get back to my point, his interjection will turn into a whole fucking lesson about the history of motherfucking Uranus. Talking about I cut the man off. You didn't see his tactics? The man interjected one time and it turned into the whole history of how we discovered motherfucking Uranus. And it had nothing to do with the narrative of the point that I was trying to make. It was just the interject in between my shit to throw me off, slow my momentum down, distracting all that. See, y'all don't debate, so some of y'all don't get it. And if I don't cut him off and say, okay, man, your interjection over, bro. I don't like what it's going. It's getting off track of where I was about to go. Then he say, well, you cut me off. Well, no, I ain't letting you interject no more. I'm an Indian giver. I'm taking it back. And in a debate, I got the right to be an Indian giver, whether you like it or not. I can allow for interjection, then say, okay, I'm taking it now back. You through. You can do that. And you should when you need to, because your opponent can use interjections to his advantage. Yeah, man, he know what he was doing. This shit is easy today. Like, he talking about some other channel they got. I'm going to have to check it out first. Somebody say I'm admitting that I'm cutting people off because I'm scared. Draco Fire, you're a dumbass, man. I'm admitting that when I allow people to cut me off, which is what interjecting is, you dumbass, that I can take the mic back if I gave it to you. That's called being an Indian giver. I ain't cut nobody off if I'm allowing them to interject. If I allow a nigga to interject and I'm so kind and he try to change the narrative, I'm gonna say, okay, I changed my mind. Give me the mic back. And I'm cutting him off. I let him cut me off, which is what interjection is. But if I don't like where he changing the narrative to in a debate, I'm gonna stop him and say, nope, you can't interject no more. I changed my mind. You changing the narrative now. We about to get a history lesson on Uranus. That's throwing us off. That's a red herring. And you never let your opponent make a red herring. To me, the part where he really lost the debate was when he tried to explain the synchronicity of the Earth's atmosphere to the ground. He wasted damn near 30 minutes trying to act like I didn't understand what he believed. And when you do that, that's to make yourself look smart and your opponent look dumb. And these little UK white boys like him like to use that tactic. If you show up to a debate repeating all the theories and arguments that we've heard from the globe, that's one thing. That's cool. Heard it all before. But when you fail to explain your science in reverse, that's the problem with the globe. Gravity explains why shit fall, but not why it rise. The speed of Earth's atmosphere on a globe only works if you moving with it. Can you move relevant to it? That's what I'm telling y'all. That's why I brought up the treadmill. A lot of times people think you lost a debate because a person, like, cause I'm an Alabama nigga and I talk country and this white boy up here talking, sounding all like he's smart, but people don't see how I'm whooping the shit out his ass. You can't bring up an argument about relevancy and not bring up the fact that in reverse, relevancy go out the door. If a treadmill moving at 10 miles per hour, if I step on it still, it's like an escalator. It's gonna move me at 10 miles per hour. If it's moving the same, you know, when you're running, you're pushing a treadmill downward. That's the way it's rotating. So your feet and traction are in unison and sync to the motion of the treadmill. If you turn around backwards and try to run the opposite direction, you might get injured. And if you speed that treadmill up and you ain't gonna speed your feet up, you gonna get pushed off of it. You can't tell me that the ground I'm walking on is moving like that treadmill and that I'm gonna gain 1,000 miles per hour because of it, but I ain't gonna lose 1,000 miles per hour when I travel against it. If you in the chat room think I lost, you just another nigga probably who facing that Willie Lynch shit. You think every white motherfucking dude is a god and smart. I mopped the floor with that damn dude. And he was mumbling all over his goddamn words on that atmosphere shit. That's why I cut the camera on him. I knew it was over then. That's the part when the refs say, oh man, it's a TKO. That's it. Ding, ding, ding. Y'all didn't get it though. Cause a nigga trying to, you know, be professional, ain't, you know, but I'm just making an argument like a grandmaster now. The people can see you make no sense. You just can't say relevant and think you won. Cause if I'm moving relevant to the motion of the treadmill in this case, I will have to account for the speed, and he didn't want to do that. He just said you can do what you want on that treadmill regardless of what speed is going, and everybody know that's stupid. Everybody know that shit stupid. If you think he won, you got to be motherfucking stupid. Got to be a fool. I got him right there with the atmosphere. Once he said is that the plane gained 1,000 miles, he know it's because the plane moving in synchronicity with the atmosphere, which is why I asked him that, and he said yes. I said, so technically, the plane moving at 1,500 miles per hour. Y'all think I was just asking him that? I'm setting him up. It's like a left jab getting you ready for the right hook. Some of y'all don't know about debates. You don't see that that boy just lost miserably. It wasn't even a fucking debate. It was a slaughter. And I did it like the wise old guru I'm becoming. Don't gotta cuss. Don't gotta yell. And yeah, I can be an Indian giver. I don't care what you say. Yes, I can be an Indian giver. If I let you interject and I don't like where you going, give me my mic back. In a debate, you better use that to your advantage. Because I let somebody interject. My opponents never let me interject. My opponents never let me interject. I let them interject. Way more times than they let me. And if they trying to change the narrative, I'm going to say, nope, no, give me the mic back, bro. I'm going to just finish my argument, and you say what you say after that. Because the whole lesson about Uranus and everything else he was saying about the whole Mayan calendar part, all of that was killing time because he knew that I had him. He knew, and I know that he lost. But he know that the people dumb. He know that the people dumb, though. Why you think I kept telling him, man, I don't want to talk about the Mayan calendar, bro. Let's get back to flat earth. Think about this, y'all. If he really think he won a debate, why wasn't he so excited to get back to flat earth like I was? That's like two dudes fighting, and they stop to drink Gatorade and shit. And one dude like, nah, to break over, my nigga, let's go back and fight. And the other one like, hold up, man, I'm still stretching. Now, don't he look scared? Because y'all know we completely got off topic with the Mayan shit. That ain't got nothing to do with the shape of the earth. No matter who win that debate, it don't prove flat or earth. So guess what I kept saying? Let's get back to flat earth, bro. And people couldn't see he was scared. If I was scared of the debate and thought he was winning, I would have wanted to keep talking about the Mayans and shit. Let me debate you about the history of when they found Venus then or Uranus. Cause why? That's me trying to dance with you. That's two niggas scared of each other in a fight. But I ain't scared, buddy. I'm gonna tell you in a debate, man, let's get back to flat earth, globe earth, cause I know you can't win on that. And when he see that I'm getting the best of him, guess what he do? Let me give you a history lesson on Uranus. Let's talk about the Mayan calendar. And I just mentioned that shit to make another point about flat earth. I was mentioning the alignment to make a whole nother field argument about the ground we walking on. It ended up me pulling up Bible scriptures, going into Revelation to prove to him that the Mayans said what the Mayans said. And I'm not debating you on what the Mayans said. If you win a debate and prove, Sanchez, you wrong about what the Mayans said, you still didn't win the flat earth debate. You're dancing. You're dancing. You rather debate about what the Mayans said than flat earth once you see that I'm a smart nigga who finna make the right arguments on you. See, y'all better peep game. You got the peep game, man. That's what I'm talking about. And this is what I'm going to do when I get back tonight. I'm opening up the panel for everybody to come on and continue to post debates, because normally in these kind of debates, you had a chat room full of globalists and flat earthers. So what we're going to do, we're going to allow globalists and flat earthers to come up and weigh in on this joint, because that's how we do it over here on Bro Sanchez. Because we don't run from no smoke. And if there's somebody in the chat room who felt like I lost, I'm going to mute my mic. I'm not like him. When you come onto my show, whether I like what you saying or not, I'm going to shut up and mute my mic, and I'm going to be professional. We putting a time clock up, and niggas can come up and say, bro, Sanchez, he beat your ass. This where he got you at. This where I think you lost at. This where I think you know why I said he won. Right? And that's what we want to hear from the people. Just like when the Cowboys play the 49ers, we finna have a post-game show. And at this time, I'm at the mercy of the people. Whatever the callers call in and say, that's what I got to go with. If the most of the people join the call, say I lost, and they show the arguments in the debate where I lost, then I have my first L on my belt, and I have no problem admitting it. But I do have a democracy over here where we going to let the people weigh in, drop the link in the chat room, come on up. You have a voice over here. You don't have to be a yes man. You can come up, and I'm not going to interrupt you, okay? And you can tell the people, you know, Sanchez, you lost on this one, and this is how. Now, the only rule is you got to say how. You got to point out, just like ESPN, with the highlights and stuff, with the sports analytics. So go ahead, y'all, take about 30 minutes. I'm going to come back in 30 minutes and have your stats ready to my people who want to be critics and analytics when we come back. And me as a debater, I got to shut up. It's up to y'all now, the critics and the analysts. So that's what my next show going to be about. And it ain't just going to be about giving the microphone to people who think I won a debate. So if you think I lost the debate, again, we want to definitely hear from you, because I want you to point out where I lost at. You know why? That's going to get me better. When you point out where he got me at, if I think you right, then I'm going to sharpen up in that area. A lot of the stuff that he brought up, I wrote down, and I'm going to go check into. I just wasn't lying to him. He gave me homework. I gave him homework. If I lost the pre-debate, let me know. If I won it, let me know. Because the main debate is what we prepping for. So I can spare a pre-debate loss. It's like losing a preseason game. I'm undefeated in the regular season. I'm undefeated in the playoffs. And I'm undefeated in the Super Bowl. So if a nigga if people agree that I lost this, for example, so what? My first loss was a preseason loss, baby. We'll be back to hear what